we're live.
Fabulous. Hello, everybody, and thank you for joining the YouTube stream. I can see some people are still joining, so we'll give it a few seconds and then we will crack on with some introductions and get you listening to some great talks and presentations today. So thank you, everybody, for joining today. It's great of you to join us. I don't know how many of you were here last time. We had a great selection of talks last time, and we've got a different selection today. But to start off, just want to again thank you for coming. And if you want to share your thoughts, experiences, or talks that you've seen today on social media, then please do use the hashtag SpaceUpLive. We had quite a good following on Twitter last time, so get tweeting. So your hosts for today are comprised by these three lovely people. You've got myself, Ryan, who's got a background in physics with SpaceUp technology, and I currently work as a software engineer alongside organising events like this for your viewing pleasure. My colleague, Ryan Laird.
Hi everyone, so yeah, I'm Ryan as well, and I'm a freelance science and space writer, and yeah, welcome to SpaceUp Live.
And Remco.
So we have Remco.
Yes, so good afternoon or good evening, good morning, wherever you might be in the world. My name is Remco Timmermans. I'm talking to you from Oxfordshire in the UK, and I am the CEO of the SpaceUp Foundation, and I owe most of the credit for organizing this event, of course, to Ryan and Ryan.
So R&R Space, we seek to foster innovation and connect new skills with the space industry. So we're all about people, ideas, and skills. So we've organised a number of events where we try to bring people together like this, and it's fantastic that we have such a wide international reach for this kind of event. So welcome everyone.
But of course, where we started was SpaceUp Leicester, which has been a really successful event in the heart of the United Kingdom, where we have an audience from lots of different people from actually various different countries came to SpaceUp Leicester before. Have about 100 there, but we have been growing year on year. Now, unfortunately, due to the wonderful COVID situation, we were unable to arrange a SpaceUp Leicester in 2020, hence why SpaceUp Live was born. But we are hoping to bring you SpaceUp Leicester again in 2021. So look out for that one. We've got a jam-packed schedule for you today. Once we've got these welcome instructions out the way and a little instruction from Remco generally about SpaceUp, we'll kick off with the grid sessions, followed by a Q&A which covers those grid sessions. We've got 8 T-5s organised for you tonight. They will explain what they are in a bit, but and then we'll follow with a Q&A. And then we've got a really cool panel for you tonight on space from home. So don't forget to get your questions at the ready to put in the YouTube chat. And then we've got a general audience interaction Q&A session where you can ask anybody on this live stream any question, or just pose it to everybody on the session generally. And then we'll of course wrap up and end and hope you've had a good night by that point. So T-5 sessions, Ryan.
Hi, yes, so T-5s, all our presenters here are told that they should have 20 slides, each lasting 15 seconds over the different 5 minutes there. So these are like really short, fast talks. There's quite a range of talks we have there tonight. Yeah, and next. And yeah, as Ryan said, we have an amazing panel lined up tonight. So this is all about space from home, how you can engage with space and astronomy here, yeah, or in our lockdown sort of situations, how you can engage with this topic.
And then, of course, we've got the grid sessions where people can literally propose almost anything they want to do with a 15-minute slot. This can be, most commonly, is a longer presentation or talk, but it can be anything from discussion sessions or even short workshops if you could fit them into that short space of time. Tonight, we do have some amazing presentations for you and talks, but more on who the speakers are in a little bit. Well, right now, actually. So we've got Martina from the AstroAgency talking about the virtual space community. We've got Mohammad talking about a microgravity test platform using gliders. That sounds really interesting. I'm actually looking forward to that. Really looking forward to that. I'm actually looking forward to all of them. And we've also got Davi from talking about space greenhouses and Mars analog in Brazil. So really, really exciting lineup there for you tonight. Brian?
Yeah, so and also the T-5s, we have again such a wide selection. So we have Eldrige from Airbus Defence and Space, Aerospace Valley, talking about space project management. Have sorry if I pronounce this wrong, Gujjati Sathvik from Space Enthusiast from India, talking about space plasma propulsion. There's Hamza Shumzi. Why I love space, so we're all here today hopefully because we love space, and we have Matthew Leach, which is talking about DIY space projects, and also like talking about Hayabusa, the other asteroid mission. Yeah, and part two we have Burt Hubert from galmon.eu looking at orbits of GNSS, Marco Romero from the Angolan Office for Space Affairs, a new space ecosystem in Africa, Andrew Kennedy talking about coincident numbers for an origin of the universe, and finally Andrey Rodionov, R2 Cloud, decoding satellite signals on Raspberry Pi. So a huge range of talks there tonight.
So we've also got a panel session. Sorry, yeah, Ryan.
Yeah, and finally there's Space from Home panel. So we have the amazing sort of Dr. Becky Smethurst from the University of Oxford and Galaxy Zoo. Ramasamy from the IAU Office for Astronomy Development, and finally Hayley Evers-King, Marine Applications Expert at UMetSat.
Fantastic. And lastly, before we move on to Remco's All About SpaceUp, I just want to do a little plug. So as part of R&R Space, we're working with a student from the University of Leeds to do some surveys into our marketing and promotions, in looking specifically at diversity around that. So we'll be emailing out a survey in the coming days, just to talk about your experiences with our marketing, our events, etc. It will be anonymous if you choose it to be. So really appreciate your time on that if you choose to do so. So, Remco, have you got your slides at the ready?
I do. So let me share my screen here, and then we will share. Can you see my screen?
Yep.
Okay, brilliant. So I will start this thing now. Hang on, press the right button here. So what I'm doing is I'm actually starting with the T-5 talk to explain you a little bit what SpaceUp is. So I just wanted to spend 5 minutes about what SpaceUp on a non-conference really is. For those of you who don't know, I did this presentation in a similar form last time as well. So SpaceUp is actually celebrating its 10-year anniversary this year. So the first SpaceUp conference was in the US, where it was founded in San Diego 10 years ago. February 2010 was the very first SpaceUp conference held in the world. And since that event, it's really moved all over the world. The first SpaceUp event in Europe was held in 2012 with about 150 people attending an event in Belgium. And after that, it's really spread all over the world. So America was first, Europe came second, and then there have been SpaceUp conferences really all over the world in every continent. And yes, that includes Antarctica. We've had talks live from the Concordia station during one of our events. And we're very proud to say that we actually covered all 7 continents. So what is SpaceUp really? SpaceUp is really a simple conference platform in the sense that it's an unconference and it's about space. And I will explain to you a little bit what an unconference is. An unconference really is the same as a conference, which has everything. It has a venue, it has a date, it has a time, it has people joining, but it doesn't have a program. The program is made by the participants. After the event is announced, people can think about what they want to contribute. And usually in the classic SpaceUp, there are no pre-assigned speakers unless we have very special VIP people, of course, but usually SpaceUp is really about the people who are joining us, you, the people who are watching us live right now. You give your ideas and organize talks on the spot at the event itself, or when we do it online, of course, we have to adjust it a little bit, but it's all about people and ideas, meeting other people and ideas. And what we see is that SpaceUp often is a very good starting ground for people to meet each other, people sharing similar ideas and continuing on to meet and develop ideas together. There's a few traditions in SpaceUp. We have, and as Ryan already explained, we have T-5 talks. It's a concept where people are supported to give their point in a very short period of time, 20 slides, 15 seconds in 5 minutes. We have 60-second to land videos. If people can't be there, they can send us a video, a 1-minute video in which they explain their point and open that for discussion. We've had several astronauts doing a 60-second to land video for SpaceUp on conferences. Normally, unfortunately, today is a bit of an exception because, well, you all understand why. We can't really hand out T-shirts and goodie bags over the internet. But this is something that we would normally do when we have our events kindly sponsored by different organizations. We always take group pictures. Again, there's a bit of a challenge to doing this online. So this is just to give you a flavor of how it's been in the last 10 years. And now with the COVID situation, things are changing a little bit, but we're adjusting, and I'll come back to that. Good food and drinks. I really hope you brought good food and drinks. I did. To go through this 2.5 hours of online sessions, and if it's really warm like it is here in the UK today, then please make sure you drink enough. Every organizer comes up with new ideas to bring people together, and bringing people together is really the heart of what SpaceUp wants to be. It's give people who don't have a platform to meet in unconventional ways. Making jigsaws during the event, during the break, is a great way to meet new people. Or having an assignment in a group, spend an hour with people you don't know, designing spaceships to bring us to the next star system in the next 100 years, all with the focus to bring people together. Now, obviously, the newest SpaceUp tradition, if you can call this a tradition, in the second live SpaceUp event is using Zoom and YouTube Live, and be creative and continue to provide people with a platform to talk about space. So as you see, SpaceUp is a dynamic concept, and it's really driven by the people who are present, by the people who organize the event, which is not always the same people, it's different people in every city, people with different ideas about how to make the events more interactive and more inclusive, and we're very open to that. As I said, the rules is just, it's an unconference, it's about space, and how you fill that in is totally up to you. So the future SpaceUp is really in your hands. So this is really a call for all of you out there to consider organizing a SpaceUp event in your city, or in this case, on your computer, doing it online. As I said, SpaceUp is 10 years old this year. So we've had 10 years of over 100 events all over the world. So I would like to thank you for being with us and making SpaceUp the great thing that it is today. So thank you very much.
Thank you very much, Remco. That was a fantastic talk introduction to SpaceUp. So I guess we'll kick off with our grid sessions, and we're starting off with Martina from the AstroAgency talking about the virtual space community. So that sounds like a really interesting talk. Martina, take it away if you're when you're ready.
Okay, thank you. I'm just going to share my screen here. Hi, everyone. So today I'll be talking about the virtual space community, as Ryan said. So Imagine this. You're looking out of the window, longing to step outside, aware of all the beauty that awaits, yet having to stay confined to your own space inside. Something you've become accustomed to for the past month, as the world around you rapidly changed. Except for perhaps that one time in a day when you gather all of your gear to take that daunting step outside of your safe environment, into a world where something unseen to the naked eye is hiding, capable of taking your life if exposed to it. The year is 2045. It is a perfectly normal day for the people living on the red planet Mars. The world we're living in today is not that different. Isolation has become a reality for most of us. We are living in unprecedented times with unpredictable circumstances that changes the way we live and work. Companies and people around the world have found themselves in a new situation that requires us all to quickly adapt. However, adapting is difficult, and a lot of businesses struggle with adapting to the virtual world and risk falling behind those that manage to navigate in this new space. So with online events on the rise and networking all taking place behind screens nowadays, engaging in the virtual space community has become ever so important. How can we ensure business as usual when nothing in the world is as usual? So my name is Martina Lofqvist, and I'm a business developer at AstroAgency. We provide strategic marketing and communication support for the space sector using our team's extensive practical industry experience combined with market intelligence. Our team is spread across different locations, and we've pretty much worked remotely from the start. So I thought that this was a really relevant topic for me to discuss here today. During this talk, we will dive into the ways in which individuals and companies can and should make changes in order to stay engaged in the virtual world. And we will explore how this situation will impact the space community moving forward. So the world is changing, as I'm sure you all are aware of, and it has become ever so important to build strong communities. When there is a crisis, we see people craving connection and belonging. So this crisis is a little bit different because people can't physically come together. Something like the 9/11, we were able to come together and build communities, but with this, we don't have the ability, and instead we're relying on virtual connections. Much like we are right now with the SpaceUp Live, we're switching everything to online instead, and that changes things. That changes how we build communities and how we connect with one another. So virtual connections have limitations. There was an interesting study done by Cognizant and Microsoft, as you can see here, where they looked at the effectiveness of different ways of communicating when it comes to building relationships. And as you can see, the number one here is face-to-face interactions with 93%. Obviously, during these times, face-to-face communication is a bit difficult, but there are ways through leveraging specific technologies that this can be strengthened. It also enables new connections to form with people who you might never have met otherwise. So there are a lot of opportunities, and I will talk about the advantages of the virtual world a little bit later. But one thing that I want to say is what you should do is to take these different kinds of approaches, these different technologies that you're seeing right here, whether it's sending out personalized emails, organizing a webinar or instant messaging, and then group them together to build as close to a face-to-face relationship as possible. And there's a chat going on in the live stream right now. And so please feel free to share what you're doing and what tools that you're using to focus on communication in your teams. Because I think that would be interesting for everyone to see the different technologies that are being used, what's working well and what's helping on the communication front. Internally in AstroAgency, in our team, we're using Zoom for stand-up calls and for social hangouts. And then we have a group chat on WhatsApp to share different links and information. And then externally, we also organize a weekly informal networking event to bring the space sector together. And I'm sure some of you listening and some of the organizers of this event know about the familiar space bar that we've been running for the past weeks. So now that we are relying more and more on different technologies for connecting with others, let's take a closer look at the problems with shifting to a more virtual world. I would say that the biggest problem, and I mentioned this already, the biggest issue is the lack of connection. So let's forget about the technical connection and the ever so common, do you hear me phrase, because I hear that way too often. But what I mean by this is that it's hard to get across emotions through technology and establishing a true connection to others, and especially showing empathy. And doing so through written communication is very difficult. And a lot of communication is written nowadays with emails. So although I have seen a lot more emojis coming through my emails these days, maybe to add a bit of the emotion part there, which is really nice. And then emails seem to start and end on a much kinder note as well. So it's great to see. But overall, it is very difficult to gauge the emotions that people are portraying through a screen. And even over video, it is difficult to really see how the other person is reacting in terms of body language and sometimes even facial expressions. Blurry videos or lag are common issues, but even on a 4K screen, you don't really get the same effect as if you were actually sitting in front of that person. So the ability to read others over a device will probably never get as good as in face-to-face interactions unless we develop some highly sophisticated VR, but I don't think we're gonna have that virtual reality realization yet. So that's gonna take some years. Before this pandemic, we were already seeing a big shift to the virtual world. So I just wanna highlight that for a second. And now with this current situation, we are spending more time behind screens than ever. So being able to navigate in this virtual space is very important, and your ability to establish close connections can make or break your company. Why I'm really trying to get this point across and why connection is so relevant, especially in the context of building communities, and also why do we struggle so much with it? These are things that I want to get into a little bit more. So let me briefly discuss a TED Talk presented by Brené Brown. In her TED Talk, she speaks about the power of vulnerability, and that is the #1 thing that connects us humans. So I just want to go into the connection side of things to get a better understanding of that before I move on to tips and tricks. So why do we struggle so much with vulnerability? Initiating a conversation about your salary, having to ask your investors for more money, getting laid off, laying off people. I'm sure you're all aware of these things and have been in these situations. We live in a very vulnerable world, and it is a lot more vulnerable right now. Our physical, mental, and economic health is being threatened like never before. So people could be extra vulnerable at this moment, and this pandemic is really impacting everyone. The good news is that evidence shows that being vulnerable actually helps us to connect more. And the relationships formed during these times might end up being a lot stronger than what they were before. So maintaining relationships with your current customers, partners, suppliers, and other key stakeholders, and even your local community is more important now than ever. And therefore, you should put a lot of focus into increasing your community engagement. So let's dive into this more and explore the ways in which you can build a successful online community. These are some things to keep in mind when building your online community. And I'm going to relate these all to a rocket mission because we're all in the space industry here. So I think that's pretty relevant. The #1 thing is purpose. So you have to be clear about your community purpose, because without it, it can risk brand damage, accusations of inauthenticity, and you really want to integrate the community with your brand as well. And this can be compared to the mission of the rocket launch. The second one is ownership. So having a clear ownership of the community is really important. So this can be a person, company, organization, and this person or company organization needs to devote time into this initiative as well. And community without an owner is like a ship without a captain. So the results could be very chaotic without this person or organization. The third one is platform, and I would relate that to the rocket. So carefully consider the platform that you're using, and establishing the community on social media might not be the best place. It's important to create a meaningful experience. So this is really the user experience side, and you want to make sure that it's customized. And then the fourth one is management. So a community manager is great to have. A common mistake is the lack of management when building these communities. You might think that the community can just run by itself, and this is often not the case. So it's important to be proactive with the relationships that you're trying to establish. And I would relate this to ground control. And then the next one is value. So you really want to bring value to the participants. So that's in information, updates, and also it's important to listen to your participants as well, or the people that are in this community. So it's pretty much the fuel of the rocket, the thing that keeps it going and actually reaches its mission. And then the last one is focus. So it's important to focus on the essentials, staying on track. You don't need all the additional features. You just need to make it to the destination in terms of the rocket ship. So for the rocket ship, for example, you need certain features. You need a kitchen, a sleeping place, etc. But golden seats might not add a lot of value to it. It just bumps up the cost. So when you start with this and try to build this community, make sure to make the registration effortless, and it should be easy to join. Stay on track with what you're delivering to the participants, and just have focus. So now that I mentioned these, I want to bring up an example of my own, and my example is the spacebar. I think it's a great example of community building, and we've been working on this for the past 13 weeks. So we have our 13th one tomorrow, actually. We spotted a gap that needed to be filled when all the bars were closing, and we wanted to bring this community online. So our purpose is that we are creating an engaging place for informal networking and to discuss all things space. Ownership is AstroAgency, where our wonderful creative director, Daniel, makes sure that we have moderators for the panels each week. And then the platform that we use is Zoom and Eventbrite to sign up. And Zoom has a lot of nice features for raising hands and so on. And then in terms of management, I'm usually the one who hosts it and make sure that everything is on track, except for that one time that we had a TV presenter, Dallas Campbell, who was a guest host, and he did a phenomenal job with that as well. And then our value is that we have really interesting conversations about all kinds of topics, from microgravity experiments to space superpower. And we've had takeovers by SSC, and ESA ambassadors are coming on tomorrow. VC firms have been providing advice to different startups. Networking has been formed, and students looking for roles in space. And just in general, a good time, a nice relaxing environment for people to be on. And then the focus is that we try to make it as simple as possible. So using the same Zoom link each week, same format, sending out all necessary information in advance. So we've had about 450 unique registrations so far for this event. And as I mentioned, there's one tomorrow, so feel free to join that as well. And there's a lot of nice ideas out there. It's not just the space bar. There's a lot of other ones as well, such as online happy hours, speed networking, live workout sessions, virtual breakfast clubs. And I was on a coffee hour earlier today. So these are all fun ideas. And I think this really helps with the connection side of things, and it helps to establish a community and build a community. But I would say that once it reaches a certain number, it is a bit more difficult to really feel that connection to other people. So just be cautious about that if you're organizing an event like this. Because I actually made that mistake with the space bar. The first couple of ones, we only had a few attendees, 20 people or so. So it was very easy for everyone to speak. But then once we reached 40, 50 people, it became a bit more challenging. We had 100 people join once, and just imagine everyone trying to talk at the same time. It's very difficult to follow along the conversations. So we found a way to combat it by just making small groups, 5 to 10 people for different panels, and that worked really well. So just make sure to make it engaging for everyone and really try to get that connection, because that is what makes a big difference. Although in all of our efforts of trying to establish a closer connection to others in the industry, there's one thing that is very difficult to achieve virtually, and that is small talk. I'm sure a lot of you are missing those casual conversations that take place outside of the cafe or when you're standing in line to grab some food at a conference. So online removes this opportunity for chance conversations, and that's a difficult one to combat. And if someone has an idea, please write it in the chat, because I'd be interested in reading it and learning about it. So just being surrounded by this dynamic environment rather than an empty room with a white wall. Although I must say that having these virtual backgrounds really do help, and I've seen some really funny ones on the space bar. But this new environment can also be an advantage. So let me talk a little bit about the advantages here. We are getting more personal. With the switch to online meetings, not just webinars and conferences, but one-on-one meetings, we're literally being invited into the homes of those we speak to. So in terms of business development, there's a whole other personal level being opened that you wouldn't get in a boardroom or an office. So does this strengthen our connections on some level, boost the person-to-person aspect of a first meeting? And these are just some questions for you to think about. I had a call with someone whose toddler walked into the room, and it was like an introduction to their family. And I've also had calls with people where people's pets have been running in the background. I just wanted to put up this image here. So that's pretty common. It's also much more accessible. So we are really building a global community, and the space community is global as it is, and it needs to be global. So it has been great to meet people from across the world that you might have never seen otherwise. I met someone from the mining industry in Chile, a student in Iran. We got a new customer in Canada recently. Another person is located in Egypt, and the list goes on. And this is just from my home here in Sweden. So it's great that this global community is accessible. So what about the future? What will the future of the space community look like? I believe that a lot of what is happening right now is here to stay. The communities and connections that we are making now will matter after this crisis. So let's talk a little bit more about the events and conferences in particular. They're great for building a strong community. However, we have now proven the concept about virtual networking. So it's difficult to go back to the 3 physical events happening each week. It's hard to justify spending a fortune to go to a conference on the other side of the world. The cost, time, health, fatigue from traveling to other time zones, environmental impacts, and so on. So it's almost a good thing that this has come out of it. And I think a lot more conferences will be online. But of course, the big ones will still exist and be there because we still want to go to them. And then just for some concluding thoughts, I want to close by showing this quote: "Human connection is the antidote to a culture of isolation." I thought this was a nice and very relevant quote for this talk. And if you take anything out of this conversation, I just want it to be the connection aspect and how important it is to build strong relationships during these times and to build these virtual communities and make sure to really foster them, because I think these will have a big impact once the crisis is over. So that is all for me. If you want to get in touch with me, you can find me on LinkedIn, Martina Lofqvist, or you can send an email to liftoff@astroagency.co.uk. Thank you very much. I'll be here for the Q&A as well.
Thank you very much, Martina. That was absolutely brilliant. And yeah, as Martina said, she'll be around for the Q&A. So if you've got questions, post in the YouTube chat, and we'll pick them up after all three of the grid talks have been. So the next grid talk is by Mohammad, talking about LIDE, the microgravity test platform using gliders, which sounds very interesting. So Mohammad, are you ready to start sharing the screen and take it away?
Yes. Okay. Yeah. So hi everyone. So I'm Mohammad, and I'll be talking to you from Belgium about gliders, as you can see. And yeah, so you'll see by the end of this talk how they're related to space research. So as you know, when it comes to space hardware, everything that you send to space, they need testing. You have to work on validating and verifying how they're going to perform in the space environment. And for that, you need to do a lot of testing. Even though space is not technically that far away, you know that when you look at the ISS orbit, it's going to be around 400 kilometers away. It's not that far, but the environment is just so different that we need to put in place methods and tools so that we can actually test everything that we're sending into space. You have, I mean, as you know already, a lot of like challenging aspect of the space environment, and then there is one thing that is that we don't really find on Earth, and it can be very useful for some scientific research as well. But also, you have to prepare for that when you send something to space, which is microgravity. The fact that in space you're not going to have the same level of gravity that we experience here on Earth. So I'm going to be quickly talking to you about some microgravity platforms that we have here on Earth to recreate those conditions on the ground, and then talk to you about the LIDE glider platform, which is the startup I co-founded. And at the end of it, I'm going to send you a link, and there is basically a call for experiment. We're going to have in early 2021 a free microgravity ride. So if you already have an experiment that you have in mind, you can actually apply, and hopefully you'll be selected. So to quickly, microgravity environment. So first of all, why you need it. So for science itself, like even if you're not sending anything to space for the purpose of space, there are a lot of scientific research who are looking for that kind of conditions, because it's one parameter, so the gravity, the acceleration due to gravity, that if you remove from your experiment, you can actually find new things, and it can be very helpful for your research. So in fluid dynamics, that's something where you try to find ways to remove the gravity to see different phenomena taking place. And also sometimes you not just for research, but you're trying to see practically how would those liquid behave in space. For example, when you're thinking about the liquid tanks of spacecraft and satellites. In theoretical physics, there's a lot of experiments who are looking into different aspects of physics of particles or matter, who are looking for that, especially at cold temperature. And then for material sciences, again, when you're dealing with very lightweight structures or nanomaterial or different temperature properties, it's also a good thing to be able to recreate lower gravity or microgravity conditions in your lab. So there is a lot of need for it. And at the moment, there are different ways of recreating that. One of the easiest way is actually to use a random positioning machine, like the one that you can see here. What all this does is that it starts just rotating in all of the direction, and you're going to have the gravity vector, which is going to be straight down. But because the sample is moving in the 3D space, on average, you can have, like the gravity vector on average is going to be the same in all directions. So for some experiment, for example, this is already enough to just see what type of effect you can have. Obviously, it's going to depend on what the experiment is for. It's not useful for a lot of things, but it's very niche, some very niche research like, this would be enough for them. Another platform that is used is the drop tower. So in the picture here is the one in ZARM, and you can, so the way it works is basically you have your experiment at the top of the tower, you drop it, and during the free fall, your sample or experiment is going to also experience low gravity. Something else you can do is sounding rockets. So here we get a bit more expensive during the ballistic portion of its trajectory before it falls down, before it crashes basically on the ground or is recovered with the parachute. You're going to have again some part of the path which can be where your experiment basically is going to see low gravity. And then I think this is the most famous one, which are the parabolic flights, usually done with airliners, so huge aircraft. And what they do is that they have this parabolic path. They speed up and then basically deep nose down. And by doing this, they can, for a section of their path, basically they can again offer low gravity levels. So all of these, as you can see here on this slide, so they each have like different opportunity, different benefits. They're good for different things. Their cost obviously is different, but most of the time, really, they're not really accessible. So, for example, the most useful one would be the commercial parabolic flight, because of the time that you're going to have, the duration of the weightlessness that you're going to have during the experiment. But then you have to sign up like a long time before. You have to pay a lot of money if you're not doing it as part of academic research. So we were looking at this and we thought that basically there is a room for another platform, and that's what we. And that's what we thought about using gliders, basically. So gliders are low cost, and because they're much more easy to move around, you don't need to wait that much in terms of lead time. You can have a lot of them. They can come to you where your experiment is, and really and obviously they're more environmental friendly. So we think that there is room for a glider-based platform, and that's what we try to do. So this has been done before. So there are some papers who have looked into the opportunities with gliders. And basically what they showed is that, yeah, you can probably use gliders and get, below 6 seconds of 0G. But it wasn't really characterized in a systematic way. So what we've done was we built some sensors in flight data recorders, using Arduinos and Raspberry Pi system, and we just attached it to the end of, to the back seat of a glider. That was, our first attempt, just to see, try to characterize what would it look like in terms of acceleration if you were doing parabolic flight with gliders. So we have a pilot in our team, and you can see, so on the right side, this was basically the first prototype of our flight recorder. And so you can see the attempt here on this video if it plays, and on the right side you can see basically the data that we had. So you can see on the top right, you can see the spikes. So these are the acceleration seen by our recorder. And every time that you go, you're at the top of your parabola, basically, you're going to get like 5 or 6 seconds of low gravity that can be actually useful. So that's what we managed to demonstrate with this first test flight. And you can see on the left, it's quite a fun video, but that was just us playing with a glider and putting a sensor on the back, and see how far we could get and how close we could get to a very good low gravity. So this proved that it could work. We then after that we tried to look at how how repeatable it was, and we done a lot of flight tests, and basically we see that you can get to below 0.2 G quite easily, usually around 0.1 G, and the interesting phase can be as long as 5.5 seconds every time you do it, and you can probably do about 15 or 20 parabolas with a glider before you need to find a way to go back up. So it's quite repeatable. It's quite nice because you're not the gliders have very good aerodynamic profile. You don't have a lot of drag, so you don't have a lot of parasitic acceleration in the axis that you don't want. And also by adapting the shape of your parabola, actually you can recreate other intermediary gravity levels. So usually at the moment in the industry, in the research, they have a lot of value for 0G when they send something to space on ISS, and for 1G when you're doing your experiment on Earth. But they don't have the values for those, intermediary steps. And with the glider, you can actually adapt your flight path and try to recreate those other levels. So a question that you might ask is, why should you use a glider and not, just a small aircraft that might also be cheaper? And so what we've done is to show basically the level of jitter and the vibration that you can see on an aircraft is going to be so higher than what we find on a glider, because you don't have any propulsion system on the glider. So for this reason, it can actually be quite good. So the back seat itself, so this was a prototype. We're looking at a lot of different ways of implementing this, but actually you can have something quite heavy and quite big in the back seat. So that's why the glider platform seems to be quite nice. We also worked with some students from the University of Louvain here in Belgium, and as part of their master thesis, what they've done is that they worked on a design for an experiment rack. So the idea of having a standard rack on the back, and then everybody from different university or companies can come just with a small box and just attach it to that rack and then fly the experiment very easily, and with keeping the costs very low. So we would then just provide basically a power supply to their experiment, and also take the data and transmit them back to a ground station with this standardized payload specification. In terms of cost, we're trying to compare it basically with the other opportunities that you might have when you're looking to do microgravity research. And actually, so a flight with a glider, you can get, as I said, between 15 and 20 parabolas, each of them between 5 and 6 seconds. And the cost of it for the end user can be as low as 50 euros per second, which is quite economical compared to the other alternative. So if you have any experiment, because you're working on a technology that has never flown, you have a mechanism, you want to see how it would do in space, get in touch with us. Or if you are just a student and you have an idea, so we have a call for experiment at the moment. So we haven't published it yet, but this is just a form that if you want to just show interest, we'll send you then the information in a couple of weeks. But the idea is that we're going to have basically a glider flight in early 2021, and then at that period of time, you could have your own payload. Any experiment that you have, it doesn't have to be for science. It could be just for fun. It could be something artistic. Anything that you want to see in microgravity, you can get a video of your experiment and the data that you record or that we record, everything together. We can do that together. So that's it. I just wanted to show you what a glider does and how it can be used for microgravity research and in space actually. So I'm open to questions whenever the time comes. If you have any question, feel free to go on the website, LIDE Space, or email me. So bit.ly/freelide for if you have any interest in the next year for microgravity flights.
That's brilliant. Thank you very much, Mohammad. That was very interesting. And we had some comments, some positive comments on YouTube for that. But yeah, as Mohammad said, there'll be questions after the next grid session. So remember to get them lined up to put in the YouTube comments, and we'll pick them out. So we've got our third and final grid session of the evening now by Davi on space greenhouses, proposals for an analog station in Brazil. So that sounds very interesting. Davi, you ready?
Yeah, sure. I will share my screen now.
Yep.
So, good afternoon from Brazil for everyone. I'm Davi Souza. I'm a researcher at the Mars Analog Station in Brazil called Marte. And then I'm here to present you some of the proposals that we have made with our experience in the habitat Marte related to space greenhouses. So our motivation was more related to the previous experiments that we have in the literature related to the VEGI and the APH that is in operation at ISS. And also we looked for some concepts that we have of space greenhouses and some experience that we have on Earth, more related to the food production systems. As you can see here in the left picture, this is the greenhouse of it's called the Lunar Mars greenhouse. That was a simulated greenhouse at the Arizona University. In the right corner, you can see the greenhouse of the MDRS, the Mars Desert Research Station. So in both systems, as you can see, we have one main challenge that is to provide in situ food production. And that's why we in Habitat Marte are trying to find some kinds of solutions for this kind of technologies. So more challenges related to the food production and in space. One of the biggest challenges is to grow crops there. I think most of we already know that the behavior of the plants, of the crops in microgravity and confined extreme environments is really different from what we have here on Earth. And then we have some other challenges more related to, as you can see there, and like the supply food. The idea is to supply food demand for long-term manned missions, and also to provide the necessary nutrients for crew members. These are the most important things that we have related to the astronauts. So we need to keep them alive, and we need to be providing the nutritive meals and also tasty meals. And then also we have the idea to provide in this kind of environments a self-sustainable and resilient habitats. And then food production is one of the topics that is more important when we are talking about self-sustainable habitats. And also we need to consider the water management or other resources and such as water management and also energy supply. And then this is really important to support the exploratory missions and future missions that we are trying to arrive on Mars, and also to build a settlement on the moon and other exploring activities. More related to the greenhouse facilities, these considerations, it's more the most important that I take it here to present to you, but we need to consider that we have a lot of other concepts that we need to study and understand better to try to develop a design, a great model for the greenhouse facility in space. Don't matter where, if they will be on the moon or Mars, but the water needs to be rationed and recycled. So all the resources that are involved in this kind of systems need to be saved and reused in an efficient way. That's why we have the closed loop systems, where all the wastes and all the wastes and all the resources are reused, and we are always trying to find good approaches for these resources, and trying to see how they will be using for the greenhouses in a smart way. Then we need to consider that these structures need to be efficient for crop production, and we need to avoid the radiation, to avoid the outdoor environment and all other influences that could be affect in the crop growing. And also more related to the risks, to avoid risks, we need to consider that these chambers, these growing chambers need to be more of it need to be decoupled, and also to avoid some risks of contaminations and to avoid more losses in the systems. That we need to keep a regular food production, and then to provide the meals regularly. And I think this is the most important topic related to the greenhouse, that these environments need to be circular, and the resources, as I mentioned, the water, the power supply, and also the wastes need to be reused, and also we need to find good solutions for this reuse. Some support technologies related to the greenhouse. Some objectives that we have is to enhance the system reliability, to provide an optimal growth and high yield, and also control the environment and monitoring the crops. As you can see in the right picture, we have some life support overviews and topics related to environmental monitoring, atmosphere management, and water management, and all of these systems, all of these technologies need to consider some of these three topics to help and support the crop growing in space. And then some solutions, maybe we can think solutions related to artificial lighting, the use of LEDs, also sensoring and automation techniques, and robots associated with artificial intelligence and machine learning, and also computer vision. But on the other hand, in Habitat Marte, we try to find other kind of approaches and other kind of technologies to apply in our greenhouse, and it's more related to sustainability. And then, as you can see, some features, we have economic practice of the resources and also of the materials that we are using in the system. And also we try to provide an awareness and an education approach to training students, local students, and also to present them how could be used, how space research could be useful for our local community and other vulnerable places in the world. And then we are also providing guidelines for plant growths. I will be speaking better in the next slides. We are always trying to develop protocols to assist in the plant growth, and also to achieve a better management of the whole system. And then, as you can see, we are providing some instructions that are really committed with the sustainability, with sustainability system, sustainable systems. And then some technologies that we have there is the aquaponics. We have, for now, we have two systems. That is the grow bed, as you can see in the right corner, the grow bed system, and also the deep water culture, the DWC system in the left corner. And as you can see in the pictures, in the other pictures, we have some harvesting activities to harvest the foods and also process the tilapia fillet. The aquaponics systems is a system that we are producing not only crops, but also we are producing tilapia and some fishes to provide protein source meals. And some accomplishments of the biohabitat greenhouse, we have the development and the evaluation for the protocols, two protocols that are into operation until now, that was operating until now, is the protocols for food cultivation and the food system maintenance. These are the two main protocols that we are making some evaluations and to see how it could be applied in future space greenhouses. And some routines associated with these protocols, we have the water management, that we are always observing the water flow and the water quality of the system, some analysis of the crops, and also to see if there is any disease or pest inside of the system, also collecting environmental data, and to also observing how is the fish health, and to see how much biomass is produced in the system. And more related to the sustainable approach, we have the recycling practice inside of the greenhouse that we are trying to active in the most part of our activities. As you can see in the right, these are some parameters, physical, chemical, and also visual analysis that related to the parameters that we collect there. Some routines just to see, we have the pictures of to see how is the crop development, the health of the fish, the water quality analysis, water replacement, and wastewater reuse. And as you can see in the right top, this picture, we have an experiment that we have made in the last missions that we were reusing the roots of the plants as a substrate for other systems, as a substrate for the plant growth. We also had the Space Aqua. It's a smart aquaponic system for space, arid, and circular environments. We are trying to find aspects related to automation and coding for food production, the application of protocols, the better tracks performance of the system to reduce the workload that we have inside of that we have during the missions. And also we are trying to see some applications in space habitats in areas affected by climate change. This was the last mission that we have. We are doing some missions in virtual ways. This mission, we have participants from around the world, and we also discussed a lot of topics related to space food systems. As you can see here, some results. We had this protocol. We had a lot of brainstorm with routines to propose guidelines for the development of new protocols, as you can see there, and all of these protocols. And we also have some future initiatives related to the implementation and evaluation of new protocols. And we also are trying to focus on sensoring automation and IoT technologies to guarantee the reliability of the system in future space environments. So thank you very much. This is my email, and I also free for questions to answer all the questions. And this is the Habitat Marte website, and also our social media too. Thank you very much.
That was brilliant. Thank you very much, Davi. Very interesting talk indeed. So now we've got about 10 minutes in the schedule where people from the YouTube audience can just comment in the YouTube chat some questions, and we will put it to the three speakers that have just been and see what their answers are. We've actually had one already, and this is posed to all three speakers, or well, yeah, all three speakers, I guess. So this is from Alex. He says, one question I have to the presenters is have they found funding their concepts? Have they had to go to a traditional VC, which isn't great for long gestation concepts? So if any one of you wants to take that, then feel free.
Hi, yeah, so I can tell about the LIDE project. So I think people underestimate probably how much you can do just by working, you know. And I think the time you spend looking for funding at the very beginning, you can get a lot of you know, your prototype, I think you can get it done. So that was our case. So we were 4, and it wasn't a lot of you know, it wasn't a lot of expense. So we're renting the gliders, and we had something that we just put, you know, prototype boards, and then we stick it to a glider, because the point was just to see how it works. And then now we're working on our business plan and talking to people, and, you know, working on the pricing and costs and everything. But you can get, I think, to a point where you have hardware, you know, for example, like we got people from the University of Louvain-la-Neuve working for us on designing a hardware for a rack for us, which is not costing us anything because it's just part of their master thesis. They're interested in to have something interesting to work on. So I don't know if it's the case in other places, but in Belgium, for example, you can go to a university, say, I have a nice project. Does anyone want to work on it for free? And they say yes.
All right, that's brilliant. Thank you very much, Mohammed. Does any one of the other speakers want to also answer that before we move on to the next question?
I probably can't say that much about the virtual space bar, but I have worked on a satellite project with students before, and our approach was to get grants, and then also we made a GoFundMe page that worked very well. And as Mohammed said as well, we got some master students to work on certain projects, and that's a cheap way to do it. And then just trying out different components ourselves, hoping that it will work out instead of buying off the shelf, because that's usually much more expensive.
Brilliant, thank you. Okay, so we've got another question now from Jeff, specifically to Martina. He says, is the space sector any different to other sectors when building a community? Okay, that's a great question. So I've been involved with the financial sector quite a bit before moving into the space sector. And I would say, yes, it's different for us for some reasons. So one is that it's much smaller. And it's very global, and we really need it to be global as well, because I mean, you might have a launch in New Zealand, but working on your satellite in the UK, but then you have your team working out of America. So it's a really global community. So it's really important to have that community aspect as well. And then another part of it, the second thing that I wanted to mention is that it's filled with some really inspiring people. So I've noticed that people just have, a lot of people in the space community just have this vision about the future and for humanity, where we should go, whether we should colonize the moon or Mars. And I think that's really inspiring. So I would say that it is a bit different, and I can only compare to other sectors that I've been in, so specifically the financial one, but I'm sure other people can relate as well. And I'm sure there's also other industries that are similar to the space industry in that sense. That's brilliant. Thank you very much, Martina. So it looks like we don't have any other questions coming in at the moment. So we're a little bit ahead of schedule. So I've actually got one, if you don't mind, for Davi specifically. So I really enjoyed the whole the concept around greenhouses in space. Just one question: how did you start off as a group specifically? How did you kind of like get the group together to begin with to get the project going?
Sorry, I didn't catch your question. Could you please repeat?
Yeah, sure. How did you get the group, the team together in the first place? How did you build that community of people to actually start building and testing your ideas?
So we are, when the quarantine, the coronavirus period started, we started to do some virtual missions at Habitat Marte, and then we have connected to people from around the world, and also called them to participate in the virtual missions of the Habitat Marte, and then we were presenting our initiatives and to try to engage the global community and to see what we are doing here in Brazil, because it's we have a connection with the semi-arid regions and also the application of fruit production system in vulnerable areas, and then to see how we are always trying to see how space could be applied for these communities to system or to keep the communities more resilient, you know.
Yeah. Sounds good. I think we've got one more question for you, Davi, from the audience this time, if you don't mind. It's from Jim. He says, going back to the garden presentation, has any consideration been put into the additional radiation and the effects on the plants in 0G?
Related to the radiation, in these kind of systems, we need to try to find solutions for like using some green walls, and also trying to find some resource that will avoid this radiation inside of the greenhouse. And that's why this is it's really important, the use of LED lights inside of these greenhouses. In Habitat Marte, unfortunately, we still don't have the use of LEDs light, but the idea is is always to improve the system and try to find other technologies to be applied in our greenhouse.
Awesome, thank you very much. We've actually got another question for you, Martina. Ollie, I think it's directed at you anyway, from Sebastian. He says, do you have any recommendations for recent graduates who find the job market change in the light of the recent pandemic? How would you recommend they engage with the space sector? I mean, it wasn't directed at you, but I'm guessing you're the best person to answer that one here.
Yeah, absolutely. I'm happy to answer that. So there's a lot of things happening virtually, as I mentioned. There's a lot of events happening virtually. Some of the events are like this one, where you can participate in the chat. Other events you can actually speak at. So for example, Space Bar is a great opportunity to meet and network with other people, and especially if you get a speaking slot there and join the panels. So I would highly recommend joining different events and just finding out more what's happening in the sector, and just getting all of that information, and then making some connections through those events. Remco has a website called Space Agenda, so I would highly recommend that one. You can see plenty of events there. And then another way is to actually connect with people. So once again, I'm talking about the connection side and how important it is. Connect with people. You can connect with me, and I'm happy to set up a quick call and just talk about opportunities that exist in the sector. And you can do the same with other people as well. And I think that's the best way to find out. So talk to someone. If you're interested in launch, talk to someone who's on launch. If you're interested in the satellite side, talk to someone who's a satellite. If you're interested in data, then go talk to someone who's involved with that. And the things that we've been talking about today, these are people that you can reach out to. People are quite friendly and open to that as well. So that would be my recommendation.
That's brilliant. Thank you very much. So we've had some great questions and great answers there. So I guess we'll move on to the T-5 talks now. So just a reminder to the audience that the presenters are under pressure here. The slides do automatically move over every 15 seconds, which means they're under pressure to keep the pace up, and there's no going back. So first off, we'll kick off the session with Eldrige from Airbus Defence and Space and Aerospace Valley, and he's going to talk about the paradigm shift in space project management. Eldrige, are you ready?
Yes, I am.
All right, take it away then.
Thank you. Hello, everybody. So thank you very much for this opportunity. My name is Eldrige Melo, and I'll be talking about paradigm shift in the space sector. It's a phenomenon that we have been seeing in the past few years. Can we go to the next slide, please? So I am a project manager. I'm currently at ESA Superaero studying aerospace project management. I'm also a senior specialist for the ground control, operating satellites back in Angola. I've been trained by the Russian Space Agency, trained by the Airbus Defense and Space, Space Academy. Also, I'm at Florida Tech and the International Space University, working on a lot of commercial space applications, how to commercialize all the technology that we have, all the space applications. Next slide, please. Next one, Ryan. Okay, so let's start looking at the global space economy. The global space economy is estimated to be over $400 billion at the moment, and it's expected to reach $1 trillion. So if we look at this, this means that there's a lot of business in the space sector. But the point of this presentation is for us to understand where is the money coming from. It's just government input, as we know, when we're talking about traditional space, or is there room for new space companies to start implementing their solutions, their products? Can they actually make money in this new space sector? So with this presentation, I'll be comparing government side and the new space side to give you an overview. So let's take an overview of the space sector. We can look on the upstream. We have the manufacturing, the operations, and the space systems. This is where we have all the big players, where we are used to having government intervention throughout the years. If we look down on the downstream, this is where we have a lot of commercial applications, commercial users, public users. This is where we were used to having just regular startups, regular entrepreneurs starting business in the space sector. So with this presentation, I will go now to the traditional space, where you can look on your left side the activities that traditional space or governments were used to do. And on the right side, you can look at the activities that the new space companies are implementing in the space sector. You can have a lot of positioning, navigation, and timing applications, new launch systems. We're also going to be looking in this presentation. We have debris mitigation and removal, which is also a service that the new space is trying to implement. There's not much government interest in implementing these types of solution in the space sector. We're also going to be looking at energy from space. So the main comparisons, we will start at the traditional space. As I said, the traditional space is made up of government agencies and big players. It's dominated by governments and large companies with huge government contracts. For example, in Europe, you have Airbus, Defense and Space. They have huge contracts. You have Boeing in the United States. They also have huge contracts from the United States government. You have NASA. In Russia, you have Energia, which is a state-owned company. You have ISS, which is also a state-owned company that are pretty much involved in manufacturing. So the traditional space is governments taking all the action. Okay, in the new space right now, we have a lot of entries. A lot of companies are moving into the new space sector. So in the large launch players, we have SpaceX, we have ILS, we have ULA, Blue Origin. We have also small launchers like Rocket Lab. We have Virgin Galactic, we have Open Cosmos, which is a small company in the UK. We have Relativity, it's a company that is doing 3D printing of rockets. We have OneWeb, although it's going through a little bit of a financial crisis, but it's still very much promising. We also have ISI, which is a company in Finland that is manufacturing remote sensing satellites. We have Blue Origin, just for you to have an overview of the main actors in the new space sector. So what are the main activities that the traditional space or the government players they were doing in the space sector? So as you know, the governments, they are mostly interested in doing defense mission, providing telecommunication to the country, Earth observation for applications such as security, monitoring your borders and all that. So the main activities of the new space is more commercial. It's all about making money. So in the new space, we have Virgin Galactic, which is one of the companies that is pushing for space tourism. We also have the miniaturized satellites, the CubeSats, which is also, you have a lot of companies developing CubeSats. We also have a lot of companies in the new space developing small launchers. We have over 120 companies developing small launchers in the space, in the new space sector, and only about 2 of these 120 companies are going to make it. Let's talk about regulations, the difference between new space regulation and the regulation that was done during the old days. So we had the Aerospace Treaty of 1967 and the Moon Treaty of 1979. As we can see, most of the space activities were governed by these 2 laws. In my opinion, they're a little bit outdated and they need to be innovated. There needs to be a lot of innovation. When we look at the new space, they are being empowered by this type of regulations, such as the United States Commercial Space Launch Competitiveness Act, Commercial Space Program Act of 2010, the Luxembourg Space Resources Initiative. So these regulations, they are empowering small companies to get into the space sector. Let's look at the investments. Just the United States government since 2000 has invested over $7.5 billion into the new space. So what do I mean with that? The United States government has been empowering, putting money into new space companies in order for them to be able to develop solutions that the government can use after that. But these companies are not only surviving with government money, they are also surviving with a lot of private investments in this sector. If we look in 10 years, from 2009 to 2020, there has been over $19 billion of investment in this new space. Let's look at this case study of SpaceX. If you look at this pie chart, you can see that the first 10 years of operations of SpaceX, half of the money came from the United States government, and most of the other half came from private investments. So this already starts showing us how this dynamic is working with private and with the new space and the traditional space. If we look at the Falcon 9 and the Space Shuttle, the Space Shuttle is a product of the traditional space, government space, and the Falcon 9 is a product of the new space. Here you can look at a segmentation of the space sector in terms of the players. Here you have a mixture of new space, governmental institutions. So you can really start noticing the shift of paradigm. More companies, private companies, are starting to implement space technology. In terms of project management, we look on your left-hand side, you have the traditional approach where your features are fixed, your end goal is fixed, but your time and cost is very much flexible because governments, they tend to have more money and they tend to extend the deadlines of their project. While the new space companies, they don't have much money and much time, but their product is very much flexible. For example, the Falcon 1, if we look from how SpaceX went from Falcon 1 to Falcon 9, we'll have a great look at that. Here you just have a chart of how project management is done also in the space sector, which is not very different from other regular projects where you have the different phases: initiation, project execution, monitoring and control, and the closing phase. Just here, before finishing up, we have a quick example of the project life cycle phases implemented by NASA. So this is a very regular type of project life cycle where you have the concept study phase, you have the concept and technology development, preliminary design and technology completion, final design and fabrication. So although we are talking about new space and traditional space, at the end of the day, they are still doing project management in a very similar way. Thank you.
Thank you very much, Eldrige. That was a great presentation. And I know T-5 put you under a lot of pressure with the slides moving over automatically. So next up, we've got Gujjati, who's a space enthusiast from India. And he's going to talk about plasma propulsion, the future of space exploration. Are you ready?
Yeah, am I audible?
You are, loud and clear.
Yeah, if I'm audible, then I can start. Yes.
Right, take it away.
Yeah, so hello all, and welcome to SpaceUp Live. And I'm Sathvik. I'm a 16-year-old and a space enthusiast from India. And today I'm going to speak about one of the most important topics doing rounds in the current space scenario is plasma propulsion, the future. Now, plasma propulsion is basically divided into three categories. We have electrothermal, electrostatic, and electromagnetic. With the examples there, we have the definition on screen. So I'll be focusing on plasma propulsion more because it's more widely seen and used on a smaller scale. So plasma propulsion, as the name suggests, is basically accelerating a spacecraft using plasma in a simple sense. However, people get confused with ion propulsion and plasma propulsion, due to which I'll be using the term plasma propulsion more generally because, if it's going in the same direction, electric field and acceleration, then it's plasma or not. So the reasons I chose plasma propulsion is because of its high delta V and its very high ISP, vastly reaching 12,000 seconds, and also its use in deep space missions with less fuel utilization and limited usage in near Earth orbits. And yeah, the main history of plasma propulsion and electric propulsion starts with Robert Goddard in 1906, then Mr. Lyman Spitzer Jr., who's known as informally father of plasma propulsion, and yeah, so they are scientists. Then when you go to the industrial part of it, after such works, the industrial part started with Mr. Ernst Stirlinger. Rocketdyne makes the first ion engine model. NASA and USSR wrestle. Then you have Vasimir, which is taken up by Astra, and Phase 4 develops small plasma propulsion RF-based thrusters for small satellites. That's how plasma propulsion has gone out for now. Coming to the major point, yeah, these are some pictures of plasma propulsion, and you can see many types of plasma propulsion thrusters here. You have Vasimir, you have plasma separators, your radioisotopic separators, you have Phase 4 Maxwell, they call it, and yeah, these are some pictures to entice people. That's a Hall thruster. And the status of plasma propulsion as of today here is that many companies are currently working on plasma propulsion. Example, Astra and Phase 4 to be exact. And it's being used on a smaller scale, but making use of a rocket is in turn a small reality. But I'm pretty sure it'll come into effect. The plasma propulsion works on the basic principle of Maxwell's equations and also on the Lorentz force. Once you solve both the equations, you get a gyro frequency of the particle depending on the gyro frequency, which gives you an electric SHM. More the gyro frequency, you get more the speed and hence more the thrust. So these are some of the machines that I've compiled through many of my researches. And my favorite is Bepi Colombo because it uses SCPS and is going to Mercury. And it'll be really exciting to see what it does during the orbit insertion in 2028, if I'm not wrong. Advantages, as I've told you, it has high ASP, it has high thrust, and miniaturized thrusters can be used in satellite orbit maintenance. Temperature shouldn't be an issue because it's such a highly insulated engine design. So yeah, these are the advantages. Less propellant mass also is one advantage. Disadvantages, it requires tremendous amount of electricity. You might be wondering nuclear reactors, but it's very heavy to put in an orbit. And you have something called space charge limitation because a rapid buildup of positive charge and also maneuverable issues with plasma propulsion. Chemical and plasma propulsion, I just made a table head to head. As we can see, they are on the same footing, but given the fact that chemical propulsion produces more thrust per unit mass, hence that's a deciding and decisive factor. So chemical propulsion wins, but plasma propulsion is not back out. Yes, this is my dummy. This is a static plasma propulsion, as it's called a plasma separator. In terms of papers, you send it and I get them ionized with an RF-based generator, and you gain thrust using a thermal RF generator. Then if you go to Vasimir is the front runner when it comes to plasma propulsion specifically. You feed gas into the helicon. The helicon is connected to a superconductor built magnet, and the RF generator ionizes it further to produce thrust. Behind me, it's an artist rendition of the Vasimir if it goes for a space mission. And electrothermal hydrogen is basically electrothermal, as the name sounds, and hydrogen at very low temperatures tends to act as plasma, and due to which it's an electromagnetic wave resonant cavity. You ignite it with an RF generator, mix it, and again ignite it, and you gain thrust. This was by rocket bank. My vision about Europa. We all know that Europa has so far been able to harbor life as per hypothetical analysis. If Vasimir touches 54 kilometers per second, I have not considered the rocket design, not the engine spacing. It will take nearly 134 days on 2/3 of the fuel. And since Europa is almost 0.134 times acceleration of gravity of Earth, it means any landing probe can come back easily. If you use an MMRTG, it will give you really good yield and also a particularly good idea to go there. And to conclude, I would say that plasma propulsion is the best and most lucrative technology that we can use, but it has some flaws due to which some amazing people are working on. And yeah, so it can take humanity to its pinnacle and can make interplanetary missions and manned interplanetary missions a reality. And yeah, I look forward to it. It's a really good, it's an amazing technology, and I'm pretty sure it will come into reality in the form of rockets or any other bigger space vehicles and space transportation methods. Next slide, please. Yeah, so those are my references which I've used on the left, and yeah, you can just note them down. You can contact me on LinkedIn, Instagram, and mail ID, and yeah, that's it. Thank you to both the Ryans and SpaceUp Leicester for the opportunity, and you guys can shoot your questions to me. I'm really happy to answer them. Thank you so much.
That's brilliant. Thank you very much. Very interesting talk. Next up, we have got Hamza. Apologies if I'm not saying that right. Who's going to talk about why I love space. So yeah, that was a fantastic talk. Thank you. And we'll get your slides ready, up and ready. Are you ready? Hamza, you might need to unmute yourself.
Hello.
Hi, I can hear you.
Hello.
When you're ready, take it away. Yep.
Okay, hello everyone. It's Hamza Shamsi from Pakistan. Today I'm going to present to you a different perspective of uh, the paying gratitude to the space. Like the topic I've chosen is why I love space. Okay, so we, the Earthlings, the inhabitants of Earth, are curious by nature. So we are a curious being. Curiosity gives meaning to life. This is the thing. This is the only, basically, the reason we exist. Curiosity is the essence of our existence. So knowing our neighborhood is the basic right which we have actually, and when we observe and when we search the space, we get to know that above the ozone reside great companions who are helpful. This is what I believe. The companions we have, the the uh, the, the planets, the asteroids, the solar system, the sun, the moon. How important it is, the sun, for existence of life on Earth. The moon is also very important, as we know. The whole solar system supports life on Earth. Life would not have been possible without each and every entity out there in the space. The galaxy, as beautiful as it is, as beautiful as it looks, it's also supportive. It has been supportive to the life on the planet Earth. I love the space because up in the space, there's no politics. Everyone is working for the same cause. Everyone is united up in the space. Right now, we're looking at a portrait of a family. It is the family portrait of the Mars exploration machines. So we've got a family of space exploration machines who have been developed by different nations. I love the space because space is beautiful. This is a picture of the northern lights. We can see it's full of colors. So the space has the beauty in itself, and space is infinite. So the possibilities are limitless. The more we go into it, what we find is there's no end to it. Maybe we could find its end, but for now, we call it that the universe is limitless and the space is limitless. Space gives us different theories, different perspectives. As Albert Einstein said, time and space are not conditions of existence. Time and space is a model for thinking. It changes the perspective, the way we think. Space is mysterious. It holds unsolved mysteries. The more we explore it, the more we know the new mysteries that are hidden in the space. Space is diverse. We have different objects, we have planets, we have different neighborhoods. So diversity is a quality of the space. Diversity is a quality that we find space equilibrium. We find that each particle, each object out there in the space is in perfect balance. The golden ratio. This connects us to the nature. We, as every part of the nature is connected to each other. We find the golden ratio, a factor that connects us to the nature. And finally, we're communicating it. For the communication technology, we've got satellites which are up in the space above the ozone. So it's physically connecting us, actually. Thank you so much.
That's brilliant. Thank you. Great talk. We've just got a slight switch through the schedule. We're switching Matthew and Burt around. So next up, we have got Burt, who is from galmon.eu, community tracking the orbits of all GNSS.
This is not my presentation.
Is it not?
No.
But Ryan?
So what's the issue?
This is not a presentation. This is another presentation I also sent you, but this is not the one I wanted to do. I can share my screen.
Right. Oh, okay.
I can share my screen.
Okay. Yeah. If you want to share your screen, yeah, that's fine. Okay.
I'll promise. Oh, yeah.
Yeah. Do you want to share your screen?
Okay. Yeah. So. Okay, can you see my screen?
Yep.
Okay, I'll zoom through it. So thank you for your attention. This is the presentation about a project that monitors all GPS, GNSS satellites, like the European Galileo one, the GPS, the Chinese Baidu, and the Russian GLONASS one. This is a project that is aided by many volunteers. So this is the world, and every black square on there is a volunteer that hosts infrastructure that monitors all navigation satellites for us. So it's quite spread around the world. There are around 80 volunteers. We are a coordinated, crowdsourced, open source project driven by wonderful volunteers and contributors. When we started this, many people thought we were maybe a university or an institute, but we're not. It's just a bunch of hobbyists. Why did we do this? Why did we build a crowdsourced GPS, Galileo, Baidu, GLONASS monitoring system? That happened almost a year ago in July 2019, which was a simpler time. And then the EU's Galileo system went offline and for a week, and no one knew why, and there was almost no data available on why you could have a week-long outage in a global navigation system. And there were only two people really that were sharing information. One of us was the Finnish land measurement service, and there was an Italian institute. And back then on the 17th of July, I thought, how is it possible that I cannot see what is going on in these navigation system satellites? And why is no one telling me what is going on? This is a simple picture of who controls the EU's Galileo navigation system. And from this picture, you can see why no one was speaking out. Everyone is responsible for a tiny little bit, and they are not going to do a press release why it failed. So this is what we built. This is a global coverage map that during a recent incident shows which areas of the world have no Galileo coverage. And the areas in red really have no coverage, and the orange ones just have poor coverage. And we now have a live map of this that everyone can see. And if you get a problem getting a navigation fix, you can go to this map and see if it is you or not. This is the status display that we have, that for every satellite in a constellation, you can pick GPS or Galileo or Baidu or GLONASS, tells you how every satellite is doing, what the health status is, how far ahead or behind of UTC it is, how many sources from our network are viewing it, and even a live orbit and clock error. So you can see for every satellite if it is where it is supposed to be. And if it's not, you will see a red square appear. And almost any time you look at this output, and you can watch this live on galmon.eu, you will see that there is one square that is red or orange, because something is always going on, either in GPS or Galileo or Baidu or GLONASS. This is a pretty picture. It's a bit scary. This shows for every receiver station what satellites it's looking at. We are currently tracking 106 navigation satellites, which is a lot, and even more so-called signals, because many satellites transmit over multiple bands. This is a view of all that. So what kind of receivers do we have? The one on the left is 15 euros. And you can order that online. It's a Raspberry Pi W0 and a $7 device from AliExpress. And the one on the right is a very professional monitoring station that we are sort of allowed to borrow. And you could buy a car for the one on the right. And both of these contribute to the project. This is not us. This is an actual European Space Agency uplink station that controls Galileo, and you can see that it's a big dish, and there are not enough of these dishes, and you can see that here. For example, this is one of the graphs that our project generates, and what you see here is a graph of how long ago was it that a satellite last received fresh orbit information, because the fresher the orbit information, the better your localization is. And here you see that occasionally this graph goes up to 180 minutes, which is 3 hours. So sometimes there is not enough capacity to send new orbit information to the satellites, and we can plot all this. And this, by the way, is the Grafana graphing system, which is very popular on the internet, and it's connected to our software. We also have a Twitter account, which you can follow, which tweets everything that goes wrong. And actually every day, like 5 or 6 things go wrong, either in the GPS satellites or also in the space-based augmentation systems that are used for airplanes. So it's a fun Twitter account to follow. And from our amateur data, we actually find strange things. This is an oscillation in the atomic clock of almost all the Galileo satellites. And to this day, no one knows what this is. And well, it's a lot of fun because we found this as an amateur product, and lots of people are looking into it, and they're going like, yeah, that's strange. But it shows what amateurs at home can discover. This is another one. If you want to monitor the navigation satellites, they have atomic clocks on board. And if you want to know if an atomic clock works well, you too need an atomic clock, and a really good one. We don't have one. So, but what we can monitor is see if the clocks on board of the satellites, GPS or all of them, make strange jumps. If suddenly there is a discontinuity in the time. And this graph plots nanoseconds, and here you see that occasionally there is a 1 nanosecond jump, which translates to a 30 centimeter inaccuracy in positioning. And this is actually a clever technique by which we can do smart things without having our own atomic clock. Although we now have volunteers that do have their own atomic clocks, by the way. I'm gonna skip this one, but this is a fun graph, which you can all see online, by the way, yourself. We also try to be useful for the broader navigation community. When we started this a year ago, we didn't know anything, so we reinvented all the wheels, and I apologize for that. But since that time, we have also worked on our interoperability, and this is the standard RINEX format for GPS precision analysis, and we can now export our data in that format. This briefly is our architecture, and you can see we went wild on this one. Crucial are the blue things. This is where you can interoperate with the platform. So you can have get all the performance data from a time series database and analyze that in pandas and matplot and a Jupyter, and then it looks like this. So this for researchers is a really fun way to look how well are satellites doing from different parts of the world. Why did we do this? Because we have now built a sort of alternate GPS Galileo monitoring system, and we redid the work that many institutes and universities and even space agencies have done already. And we reinvented that wheel because we simply didn't know that these other things existed already. Now that we do exist, we are a sort of fun alternate resource for anyone doing research into navigation satellites. For example, we have a binary faithful copy of every message transmitted by every satellite. And that turns out to be very useful for troubleshooting. And we also focus on reporting the actual data. And that's a difference from many academic projects which report the thoughts of a receiver. So even though we reinvented all the wheels, we did add some fun new wheels. If you want to learn more about the project, you can just go to our website, galmon.eu, where you can get access to all these graphs and all this data. It's all openly available. And if you want to join in, we are actually looking for more volunteers to contribute data to the project, especially in the region of South America, where we are a bit thinly serviced. And that is hopefully the end of my 5 minutes.
Brilliant. Thank you very much, Burt. Next up, we've got a talk by Matthew from DOA Space Projects, who is going to talk to us about the other asteroid mission. So that sounds interesting. Are you ready, Burt? Sorry, are you ready, Matthew, even? Sorry.
I am ready. Can you hear me?
Yep, take it away.
Good. So, hi, my name is Matthew. So I'm going to talk to you about Hayabusa 2. I'm currently repping SpaceUp Ireland 2016. So if you like grayscale images of rocks, you're going to definitely enjoy this presentation, I think. 15 seconds. So if I just said you to think of a mission to an asteroid, the first one I think most people would think of would be Rosetta. It had a nice cartoon to sort of accompany it. It's one that got a lot of public interest, space harpoons, things like that. If I asked you to think of another one, you might think of OSIRIS-REx. That's one that's getting a lot of attention at the moment. It's an interesting one, some sample return mission. The asteroid it's visiting might strike the Earth in the late 22nd century. There's a 1 in 2,700 chance or something. But the one I want to talk to you about today is this one, which is Hayabusa 2. I don't have any personal involvement in it, but I think it's a very interesting project. And this one is from JAXA, the Japanese Space Agency. And you can see the reason I think it's a particularly interesting one is because it's a cool spacecraft that's actually made up of lots of smaller, cool spacecrafts, a lot of which are detachable, just like Megazord. So this is another family portrait, a second family portrait this time. You've got all these separate things. There's 7 individual spacecrafts, 5 reflective beanbags. And Minerva 2.2 at the bottom actually failed, which was a disappointment, obviously, for everyone involved. But there was so much other things going on. There's still plenty of interesting stuff happening there. So this is the timeline, gives you an idea of how the mission was planned out. Sort of launched 2014, arrived at Ryugu, the asteroid, 2018, and it's actually returning later this year, I think around December. So that's why it's sort of timely. So where's it going? It's going to visit Ryugu. I think I mentioned on the right-hand side there. These are roughly proportional. Ryugu is about a kilometer wide. The middle one is where OSIRIS-REx is going. The left one was Rosetta, I went to visit, 67p. But these ones, or those ones, are tiny compared to some of the other asteroids that are out there. So you can see Ryugu down in the bottom right, sort of to scale, and there's the massive one, Lutetia, and that is even the biggest. You know, there's much bigger ones than that, Vesta and Ceres. So these two are 2 of the rovers that were deployed. I've made a cardboard model of one here, and this is actually full size. This is how big it was, sort of the size of a biscuit tin. And 2 of these were deployed together at the same time. And there's a picture from one of them. So, like, in all honesty, it's not going to compare with some of the high-res pictures of Jupiter and things that you've seen, but it's taken by something the size of a biscuit tin sat on an asteroid. So I still think that's an impressive achievement there. One of the cool things about it is how it moved, because the gravity on the asteroid is so weak. It was able to just spin up a motor or weight attached to a motor and do like sort of little hops around the place. And that was set on a turntable so it could point in different directions and then just fire off. So another rover that was sent down was this one from DLR, the German space agency, a bit of French agency involvement as well. And that one moved around by basically kicking a weight on an arm, and that gave it the momentum sort of lift up in the air. I think it could go like a meter away. So this is an image from Hayabusa 2 as Mascot, which is the name of that rover, is descending. You can see the sort of shadow in the top right there as it goes down. And then on the next slide, we can see this is an image on the right-hand side was actually taken by Mascot on its descent. It's not all the way there. You can see a sort of shadow down at the bottom left of its going. And on the the left-hand side there is a reference image. So you can see that sort of trapezoid shows where it was pointing. So it also had these highly reflective beanbags that it fired out when it needed to. So if you think about the asteroid, you know, it's the big gray, no real reference points there. So the spacecraft actually made its own reference points by dropping these beanbags in strategic areas, and then it could strobe a light and sort of see them reflected, and it would know, you know, just go 4 meters left of the beanbag, and that's the target that I'm aiming for. So sometimes it would drop these as it descended. As we can see that sort of compiled image on the right, it's the beanbags. So this is sort of a descent plan. You can see around number 2 there in the middle, that's when it fired off one of those beanbags as a reference marker. And on its first touchdown, Hayabusa 2 actually, as the sampler touched the surface, fired a bullet into it. So this one is one of my favorites. So that's DCAM-3, you can see off to the right. So the small carry-on impactor was essentially a cannon that it fired to throw up lots of dust. But in order to protect the spacecraft, it went and hid around the other side of the asteroid, and it deployed a small independent camera. You can see it's the silvery bit from the one on the left, DCAM-3, to actually record the impact. So here are some still images that it took. So you can sort of see plumes of dust being thrown up. So I still think that's impressive. So the Hayabusa 2 was off, hiding around the other side. This camera, about, I don't know, maybe that big, floating in space on its own. And this is from the collection from the second touchdown. So Hayabusa 2 again sort of landed in the middle of that impact that was created. You see dust firing up. And I think the most impressive thing about this particular image is the camera that took it was crowdfunded. So we wouldn't see that without public support. And hopefully we'll see this at the end of the year. So this is the sample collection that the first Hayabusa managed. And hopefully we'll see something similar when Hayabusa 2 returns. Thank you.
Thank you very much, Matthew. That was very interesting. I hadn't heard of Hayabusa 2, so it was a very interesting talk, and excited to hear about different space missions. Next up, we've got Marco from the Angolan Office for Space Affairs, and he's going to talk about new space ecosystem in Africa. So are you ready, Marco?
Yes, I'm ready. Can you hear me?
Loud and clear. Take it away.
Okay, so Marco Romero, Space System Engineer at the Angolan Space Program. I'm here to talk a little bit about the new space in Africa and how we can set up a sustainable ecosystem. So far, we can see that the African space market is worth over $7 billion, and it's expected to grow 40% on the next 5 years. And from those big numbers, we only have 34 new space companies so far. 3 of them that are a spin-off from universities and research, and 5 of them from the government, and the other 26 from that are private companies. And if we see that altogether they could have a combined valuation of $200 million, mostly from equity, because investors, they don't have enough trust to put their money on new space because they are not totally connected to that. And if you see, African has a very big and wide picture of a lot of strong willingness of people, a lot of initiatives, politics are being set up. But I'll put a question, why we continue having for these more than 4,000 startups, a failure rate very high. So we want to rise an ecosystem that has a lot of dependency on government policies, capacity building gaps from the research institutions and universities, and the events and the showcase are inefficient. That's why we have a very high failure rate. And so far, I could start working on the mapping of all those issues, all those problems in terms of investment, acceleration, incubation, and the policy making infrastructure to help to raise this awareness and to increase the number of interest in the space industry, not only from student side, but from small and medium enterprise. And the best way I could find to do that is to see on each of those issues that you can see here in red, how what solutions we can address and what solutions we can come up to make these 24 minimum startups take advantage of all the investment, or to break the ice with the angels, business partners, or even the customers, because customers, they just don't invest enough because they don't feel confident about the added value of those startups in terms of the fintech sector, the insurtech, or those new entrants, and the political infrastructure of African governments. They have a very big role on the commercial and industrial development. If we go to the next slide, please, we will see that the first point where we will start working with will be to see and to assess how is the space industry in Africa in general, how to make this, how to have this overview, because from that, it will be possible to use my field of expertise, that is the space system engineering, to address some capacity building tools using small satellites and the system engineering good practice that INCOSE, VMI, and other institutions are bringing together to showcase a lot of the applications. If you have the enough capability in terms of space development, and if you have a good amount of applications that you can showcase for those Sathvik people that you have on your nucleus, you'll have more and more startups aware about the possibilities of usage of data to solve what we call a very huge problem for African countries. And in general, if we look to the SDGs, we will see that Earth observation itself just can direct benefit 50% of the SDGs. And if we add communication and direct space activities, we'll see that this number will just grow very, very fast. And Africa is putting this track on equality, climate change, and life on land. That's why I'm working here with some French institutions and other African space-related organisms to develop this 5 to 6 chapter book or booklet that will address all those questions, how you can make easy and affordable capacity building programs to be implemented, even if you have a space program or not, demonstrating the benefits for the ministries or the end user that are willing to have those solutions. And just to finish, who was talking to you since the beginning was a young student of the military school that then joined the aeronautical engineer at Air Force Academy, and now is working on the air and space domain in Angola, thanks to the certification and training that I've got from Portugal, France, Russia, United States, and all those countries that brought me to here and all the startups I could develop. Thank you very much.
That was absolutely brilliant. Thank you very much, Marco. So we've got two T-5 talks left for you. Unfortunately, my computer has decided to freeze. So yeah, so we've got Andrew up next from the Chronolith Project, and he's going to talk about coincidence numbers and the origin of the universe. Are you ready, Andrew? Hello, Andrew. I think you need to unmute yourself, Andrew. Sorry, we can't hear you. I don't know if that's just me.
Still don't hear you, Andrew. Sorry. You are unmuted, but. Okay.
Well, it won't be a webinar without technical difficulties, would it? Have you got your input device set up, Andrew? If you go to the bottom left-hand corner of Zoom, click on the little up arrow by the audio. Have you got your audio device selected there?
Well, is that any better?
Yep, can hear you loud and clear. Whenever you're ready, take it away.
Great. Okay. Sorry about the delay. Look, it's great to be here, and thanks to SpaceUp organisers and the University of Leicester. I'm going to talk about something a bit different, about coincidence and what it means for the nature of the universe we live in. Because without coincidence, we won't have life. The life would be too dispersed. So I'm going to explain. Next slide. Essentially, we should treat coincidence as a property. It's not just an effect of the universe's fine-tuned beginnings, but it's a property that permeates the whole fabric of the universe, just like all the other factors and ratios do. And specifically, it brings not just an effect ratios do. It specific gravity and entropy together, because without it, life would be too diverse to be interested in factors. And give you some sort of anti-dispersal coincidences at the human narrative level to give you an idea of what I'm talking about. I don't think the slides are changing. Do I have to do something to make the slides change? Hello?
We've set up the slides to advance forward. So if you want to just continue.
No, but Ryan, you're not in presentation mode, so they won't auto.
Yeah.
Forward. So if you go to presentation mode, then they will move.
I'm stuck on the first.
Okay. Sorry about this. Strange. Okay. Should we start?
Yeah, that looks
okay.
Better.
Okay. Do you want to continue, Andrew? Sorry about this. Andrew? I think Andrew's muted himself. Andrew?
I think Andrew's dropped off the call. I can't see him in the participant list.
No, I see him here, but he's muted himself. Maybe we can come back to Andrew sort of after the panel, if that's okay. I know here. No,
yeah.
Come back. I don't know what happened there.
Oh, okay,
right.
right. Okay, so we have your slides ready here. So just all right.
Okay,
do you want to continue?
Oh yeah. Look, about coincidence as a property, and coincidence brings gravity and entropy together. Without it, life would be too diverse. So I'm going to give you some kind of human narrative stories here. One, Chile. 42 years ago, I went off and lost myself in the world. I went down to South America. I hiked in Patagonia, and I met a lawyer that I'd worked with in a year before in the office. Completely unusual. He offered me a job, which in fact I didn't take. But the point is, these kinds of accidents happen all the time. But that's all they are. They are accidents. We think of them as special. But there are other kinds of coincidences that have greater meaning. And one I'll talk about Peter, the guy, because our project is based in Seville. Peter lives in Seville. He struck up a long, deep friendship with a Japanese student called Nobu. Nobu worked for 2 years, went to Japan to bring his girlfriend back to show her Spain. And she bought this guidebook, which you can see. And inside this guidebook, which is a book to the whole of Spain, there are 2 pages on Seville. And I will blow up this photograph on the right-hand side of this page. And you'll see a guy striding towards the camera. I fudged him a little bit, but he's staring straight at the camera, smiling. And this is Peter. And Nobu was completely astounded that his girlfriend had met his best friend, in the book before he met him in real life. And this created this very intense relationship, which has lasted to this day. Here's another one. A clock. My wife put a battery in a clock that had stopped a long time ago. And as she put the battery in, started up at precisely the hour that it was then. A week later, she came and sat down on the table when I was writing on the computer about coincidence. And exactly the same thing happened with a different clock, which you can see. Now, these kinds of coincidence, while they're incalculable, the probability is incalculable, they're never very significant in the way we lead our lives. And in fact, there's so much of this coincidence going on, but it's basically submerged by the sort of cacophony of everyday life. But coincidence is anti-entropic. That's the point that I want to say that needs to be made. And sorry, I've lost my place. Anyway, there are 3 types of coincidence. There's the basic accidents of life that we all happen. You can go around a corner, knock into somebody. That's an accident. The second kind of coincidence is when you have previous information has been charged, as it were, between the two of you, and you come back together, and this information creates a contact. The third kind of coincidence is one where there's been a whole lot of pre-preparations. Neg entropy has been embedded within the, let's say, the 2 people, or the 2 lines of causal lines that occur. And this means transfer of information at a very low level of energy. So it has huge potential, but doesn't cost anything. They're like an allele in the genes, the chromosomes. It's sitting there waiting to be used. Now, I'm simply going to assert right now, because I don't have much time, that the most significant, the Baroque coincidence number, the most significant one, or type 2 coincidence, is about 4. The value is about 4. These are 4 parameters you need to make a measurement. In fact, if you want to break down the quantum measurement system with the Everettian idea where the observer entangles with all the possibilities, well, you have to have a minimum of 4 possibilities, past and future possibilities, to make a measurement. The other thing about coincidences, causal chains, they connect in ways that that are not predictable by the progress of each individual chain on its own. That's why we call them coincidences. And our lives are filled with these connections. And we know the famous experiment of Milgram and Travers, who came up with this idea of 6 degrees of separation. But these weren't really separations by coincidences. If you include coincidences, you can actually bring down to many connections between people to about 3 or 4 steps. So round about 4 is the most important coincidence number. And I'll explain a little bit more about the observer effect. When you throw dice, we seem to ignore the idea that the probability you're looking for is part of the total probability of the situation, the observer effect. Your choice should be incorporated in the event. It's difficult to do this. I'll give you a bounded example. Let's say we have 6 tables arranged, and you simultaneously throw a dice on each table, and there's a neighboring pair forms. If you do it again, then you're getting a very unlikely coincidence with just 6 tables around. But if you add more tables to the setup, for example, 36 tables, then your odds within this bounded system of the double coincidence happening come close to unity. And this is why space expands. You imagine space, time, and quantum states instead of tables. You need to have inflation in order to accommodate all the possibilities of coincidence that we need. The space expansion is a necessity, and in fact, probability means nothing unless there's a space for the options to occur. We can see these coincidences are happening at every level of organization, from quarks to galaxies and beyond. The universe is actually now beginning to settle into all sorts of filaments and clumps, and that coincidence plays this role. The number 4 plays a role in these happenings. So coincidence is a property of universes. It's connected to entropy and gravity, and it determines life. For example, I'll just give you one: DNA. The distortions, the orbital distortions that occur from the electrostatic properties of the atom have created the bonds, like hydrogen bonding and van der Waals forces, from which the DNA is created. Without these distortions and without the coincidental bonding that they create, we would not have DNA. So coincidence is about us, and it's about mind. Consciousness cannot be a determined quantity, nor is it purely quantum. Observers need their own observers within to make the consequences of coincidence happen. And coincidences are proof that ontology is insufficient. So, well, I'm coming to the end here. I write more about this in the book, but what I want to say, and I agree with physicists like Lind and others who've made clear that understanding consciousness has got to be the next component in understanding the physics of how the universe is put together. And to understand consciousness, we need to understand coincidence. Sorry, they took it at a rush. Sorry about the hiccups in the beginning.
No worries. That was a very interesting talk, Andrew. And I'll certainly be looking to get some more information about your talk, because it's very interesting. I'd like to read more. Okay, we've got our last T-5 talk now by Andrey from R2 Cloud. He's going to be talking about decoding satellite signals using a Raspberry Pi. So if you're ready, we'll take it away.
I'm ready. All right. Good morning, good evening, everyone. So my name is Andrey. I'm representing the project called R2 Cloud. This project actually has a software which you can install on your Raspberry Pi and get the satellite signals and decode them and do the real space research and real impact. So you can, with it, you can decode the pictures from space, you can decode data. So the original workflow is simple. When the satellite comes over, you just download the data from a satellite and save onto the disk, which takes maybe 10 minutes or so, depending on the speed for low of satellite. And the second stage is it will take the file and demodulate it and extract the data, and it will show you on the UI. So after that, you can share with the community, share with the engineers, and help them improve space technology just by running all these things. It's based on several projects. One of it is GR Satellites, which is a great project with a lot of decoders for various kinds of satellites and different protocols. But this built mostly on a Python, and it's really hard for an average space enthusiast to build and run themselves. So, and the second project is the GNU Radio, which is again more advanced and more technological. But I built a project which combines them all. And my project is very stable, so it has a lot of tests, and you can actually see how the data look like just by navigating to the repository. And it took me several years actually to build it, because I have no idea how to decode the satellites at the first place. But I learned, and I merged all the several projects all together into a single one, which is now a one-stop shop for every kind of telemetry and data. So in the result, you can see the web page which shows you, this is a web page from a Raspberry Pi. It contains the telemetry from AUSat-4 satellite, and you can see your real data from space. Yeah, and you can see there are a lot of satellites, and they can be decoded locally on your Raspberry Pi. And you can analyze it and just help the community do the analysis of their spacecraft. Then you can share this data with another R2 server. So if you have several Raspberry Pi instances running, you can merge them and combine in a single R2 server instance. And from that, you can just share with the community. As a bonus, this one can decode telemetry, but it can also decode weather images. So this is weather images from Meteor M2, and you can actually see what's up in the sky when the satellite comes over you. And this is a real space data which you can play with and can tune and can tweak, and you can actually put your hands on and do whatever you want. So this is run locally on Raspberry Pi, and this is written from scratch in Java and a couple of C libraries which are just dependencies on it. You can see this nightshade. So all you need is several hardware components, of course. So this is antenna. This is mostly the basic one antenna. You can buy it at Amazon, eBay, whatever you want. It doesn't provide very good characteristic, but with this antenna, you can decode images. This is a stick which actually translates the electrical impulse from analog world to digital world and save it onto the file, which you can, which the AutoCloud will demodulate and process further. And this is Raspberry Pi. This model is supported. It works really well, and performance is okay, but it can be improved. But still, you can get the data and you can get the satellite images on a Raspberry Pi. You don't need to buy really expensive hardware. So again, the performance is okay. So the whole setup is running on Raspberry Pi. For the CubeSat beacons and the telemetry, it needs maybe 10-15 minutes to process it. And for weather, it takes much more. Also, there are some performance metrics which we as a community always tune and improve and make make AutoCloud as a really good thing to deal with this with satellites. In the future stage, there would be more and more satellites, more and more protocols, SpaceX launches, whatever you want to add there. Moon missions, anything you want, just come join us. Super easy for everyone just to install your software and you're contributing to the community. Thank you very much for your attention. I think this is it.
Brilliant. Thank you very much. Really interesting talk. Right, we're running a little bit behind, so I'll only take one or two questions from the YouTube chat, and then any more questions we can cover in the interactive discussion Q&A session at the end. So I'm just looking in chat now. Let's have a look here. Okay, there's no questions at the moment. It seems I've just asked the chat, so we get any quickly. Otherwise, we'll move on. No, okay. Ryan, do you want to move on to the next part of the evening?
Hi, yes. So the next part of our session is dedicated to space from home. So space from home, we're because so many people now around the world with all the coronavirus, of course, are in lockdown. We're looking at different ways of engaging with space and astronomy. So I'll briefly sort of introduce each of our panelists here. So first we have Ramasamy from the IAU Astronomy for Development. Do you want to just say hi, Ramasamy? Oh, you're on mute.
Okay, got it. Hi everyone. My name is Ram. I'm based in Cape Town, South Africa, originally from India, and like Ryan said, I work at the Office of Astronomy for Development of the IAU.
We also have Becky Smethurst from the University of Oxford, involved with Galaxy Zoo. Hi Becky, do you want to introduce yourself?
Oh, I think you said the most of it. Yeah, astrophysicist, usually found working on galaxies and supermassive black holes, all thanks to the efforts of the public.
And finally, we have Hayley Evers-King from UMetSat, so marine applications expert.
Hi everybody.
Hayley.
Yeah, I'm Hayley. I work a little bit closer to home than everybody else, mostly working with low Earth orbit satellites.
Yeah. So, so as I said, most of us at the moment, we are in some cases stuck at home, and we're sort of interested in engaging different ways of getting involved in space and astronomy. So, so maybe first of all, if I could kind of give a short kind of introduction to the sort of work that you do in this area, and in terms of education, outreach, astronomy, and then we'll sort of go into sort of different questions. So, so first maybe Ramasamy.
Sure. So the IAU is the International Astronomical Union, is the professional body of astronomers, just like you have, I guess, the IEEE for engineers. So the IAU has different offices. Like I said, I work in one of the offices in Cape Town, but we have dedicated offices for outreach and education. So today I'll probably just give you a rundown of the various programs from the different offices. And another thing I want to focus on today is how we are trying to cater to groups which don't necessarily have good internet access or any internet access, because a large portion of the the humanity don't have access to everything that many of us here do. Yeah, so that's what I'll be focusing on.
Oh, Becky, do you want to introduce yourself a bit more there?
The Zooniverse, yes. So the Zooniverse is sort of the opposite to what Ram was just talking about in terms of people who don't have internet. This is for people who do. It's a citizen science website. So it's a website where we get the public to log on and look at real scientific data and classify it for us. Now, it's not because we're lazy. It's just because there's not enough of us to actually go through the volume of data that we're collecting. I think people will recognize this idea of, big data. It's a real buzzword in science these days. But what do you do once you've got all that data? This sort of was really pushed off in 2007 by a project called Galaxy Zoo, which is the project that I work with. It was an effort to classify images of a million galaxies that needed their shape classifying. So whether they were a spiral shape or whether they were just a blob shape. And that's something that, anyone from a sort of 9-year-old to a 90-year-old can do. And it really has sort of took off from there. A lot of astronomers were sort of saying, we have the same problem. I've taken images of the entire surface of Mars and I want all the craters labeled and now can't do that. Or I have all of these images of gravitational lenses that I'm trying to find. And then even we got, other scientists from other different disciplines as well. So I'm really glad that Haley's on the call from the marine side of things because, we have things looking at the ocean's floor and also like weather logs from ship data, and then also all sorts of different projects from around the globe, which is always fantastic to see. And basically we have over 1 million people helping out worldwide, and it's a fantastic site because it lets you get involved with science. So when we publish a paper saying this is the science we've done, we're like, here's all the authors, and then, oh, by the way, here's these 300,000 extra people that helped out because they classified on this project. And so you become an author on a paper as well, which is pretty cool and a useful thing to do with your time during lockdown if you're looking for something new to do.
And finally, Haley, do you want to talk a little bit more about the work you do at UMatsat and education outreach?
Yeah, sure. So the majority of my job is about getting the amazing Earth observation data that we can get from our satellites into the hands of people who can use it across the world every day to society's general benefit. So this necessitates like a huge amount of outreach, training and education, as you can imagine. And it's not an easy thing to do because the data is big, the data is complicated, and trying to get it across to the diversity of people that actually need it, everybody from business owners to policy makers, fishermen, scientists, you name it, right? We're dealing with a very, very broad range of people. So that comes with its own challenges, but also makes the work we do very important. So we've been looking at lots and lots of different ways of doing this. We run training courses. We've more and more recently, of course, been doing things like webinars. We've run massive open online courses. We do all sorts of different things just to try and get that data into the hands of the people who can really make the most of it.
I guess my first question, I suppose, both to sort of Becky and Haley in this, because of being at home and of course with internet for many people, but I'll come to Ram sort of after. But have you found much more of an uptake in sort of data here? Applications through both Galaxy Zoo and also looking into the sort of applications and the online courses. So maybe first, Haley, if you.
Yeah, I mean, it was funny, like a year ago, we were thinking, oh, we should definitely do more courses online. It makes it easier for people all around the world to access things, it stops the limitation of people having to travel, and reduces our impact on the environment, something we're all trying to do. So we'd had this lofty dream of kind of doing more online stuff in this year anyway. And then, of course, COVID-19 came along and here we are. And it's been quite interesting. I mean, I think there's been a mix of challenges for people struggling to find time to fit in these things. And we've tried to be cognizant of that, the way we've designed our courses so they're flexible, so people who are at home, homeschooling a couple of small kids can check in later. They don't have to set aside specific times. But we've also had a lot of really interesting responses from people where they've said, I wouldn't have been able to come to this course if it hadn't been online. And, that's really great. So I think we're definitely going to keep doing kind of what we're doing. And we've learned a lot about how to kind of make online interaction more effective.
And Becky.
Yeah, we, especially on Galaxy Zoo, I do know the numbers. So we saw our classification volume triple in the first month of lockdown back in April, which was, you know, fantastic to know there was this sort of minor silver lining of some more science being done, which is always fantastic. We were sort of didn't really know what to expect, because we always sort of push the Zooniverse as, you know, something you can do like on your commute, on the train. It's very easy. It's just a few clicks, you know, and a way to sort of spend your time that's still very productive. Even if it does feel like you're on your phone, you know, you could be clicking away on something like Angry Birds or something, but instead, you know, you're contributing to science. So we didn't know how that would work if people weren't commuting anywhere anymore. But actually, we've seen this huge uptick. And I think that's just from a desire from people to feel productive during this time, when it can feel like you don't have a lot of time and yet you do have all this time on your hands. And so I think it's really nice that we really are seeing an uptake in not just clicks in terms of classifications, but also engagement on the forums that we have as well, where people are like, oh, hey, I've seen this really cool galaxy. Has anyone seen anything like this before? You know, or this one looks weird. Can you explain it to me? That kind of thing. Like, it's really nice to see people get more engaged, and also see a lot more kids getting more engaged as well through sort of at-home learning too.
Thank you both. For Ramasamy, I mean, maybe you could tell us a little bit more about the projects you're involved in that aren't based on the internet, and how you're supporting developing communities with the IAU.
Yeah, sure. Well, we also have a few programs online, but I'll come to that later. So, like I said, there are lots of communities around the world which don't have any internet access, and then there are those who don't have, you know, strong enough internet to, for example, watch a live video or even just any video. So we recently launched this special call for projects about a month ago, asking people from the astronomy and space communities to sort of take up the initiative and help support their own communities in the regions. And we have had a number of projects wherein people are developing new materials or adapting existing materials, and then delivering the materials in physical form to these communities. So either through the post, one project, for example, is using a network of food banks to deliver the educational materials. And obviously, there's a lot of other thought going into this as well, because many of the target audiences, they might not have the necessary support at home to help the children or the, you know, whoever is learning, the students, learn these materials. So obviously they've got to be very self-explanatory, and it needs to be very hands-on to keep the interest of the students. Make use of, for example, the night sky or the natural laboratory that some of the audiences may have access to. But so far, like I said, many of them have taken this route of physically delivering materials. And there are other online programs as well. But I would also use this opportunity to appeal to everyone watching to sort of think about how we can help these communities. So most of you are science communicators or passionate about space, and, you know, have this knowledge about space and astronomy. And how do we keep the rest of the world engaged during this difficult time? This could take months, maybe even longer. But maybe if you come up with good solutions, that could be applicable later on after COVID as well.
Fantastic. I'm just sort of looking if there's any questions sort of online. Yeah, Burt, yeah, people feel free.
Chat yet.
Okay. Ryan, do you have any particular question there?
So, I mean, I guess in this time we've kind of already touched on it a little bit, but I think one of the biggest things a lot of parents aren't able to send their kids to school and not getting that education. So, I mean, it's kind of a two-pronged question. Do you think this time is a great opportunity to get more kids involved in space, interested in space, than you would have been able to sort of before, through the schools, because of lockdown, people educated from home? And also sort of, I mean, it's kind of more of a follow-up question, but I mean, could we point some people at relevant place where they can get these resources from you, either sort of understanding whether you do have any of your education materials online, for example, and things like that. So I guess it's to all three people there.
Yeah, do you want me to answer first?
Yeah, go for it.
I think Becky sort of had a hand up there, but okay.
Oh, sorry.
It's okay. Ram, go first. You're all right. Go ahead.
Okay, sorry. Yeah, so maybe I'll take the second question first. So we started putting together this list of resources a few months ago. I mean, initially, we didn't know how long this situation was going to last, so we didn't really think too much before starting this list. We just wanted to create something that people could sort of refer to as a first step towards, exploring their passion for space and astronomy. But now we are, 3-4 months down the line, and this list has sort of become this monster document with lots of links, lots of resources. So we are trying to categorize things and help people access this list easily. But there's plenty of stuff on there, including things like citizen science, hands-on activities. We try to categorize by the age of the target audience. So if you want to search for resources for a 12-year-old, so you just go there and choose the appropriate section, and there's tons of resources. And this is, by no means exhaustive. There's so many more resources that people are constantly developing, and resources that previously existed as well. Let me stop here.
Yeah, and I was going to say, with the Zooniverse sort of central focus that I'm sort of here with, I know that for each of the projects and also collated, the Zooniverse have put together a lot of sort of education resources in saying, okay, here's a lesson you could go through with this project. And it is amazing how much you learn from a project. We have one, in fact, nothing to do with space. It's called Snapshot Serengeti. It's literally camera traps in the Serengeti that take an image every time something moves past it. They end up with 70% pictures of grass just waving in the wind mostly. But like from that, I have learned the difference between a Grant's gazelle and a Thompson's gazelle just from classifying. And it's these things that you pick up that are sort of those little education things that you can then follow up with the sort of classroom tools that we've put together as well. People in Oxford and people at the Adler Planetarium in Chicago, which is really nice. And that, again, as Ram was saying, it's also like done by curriculum level as well, which I think is really nice. As for sort of more astronomy focused things, I know the University of Cambridge have been doing some really nice sort of like lessons and lectures, I guess, but aimed at school children during the lockdown, which is really nice. I think we had a chat sort of Oxford lot sort of talking about what you could do as well. And we sort of said, oh, maybe it'd be nice to do live stargazing. And unfortunately, sort of we're now competing with, the fact that it's the middle of summer and it's the solstice. And if you want kids to stargaze, you're going to have to keep them up between sort of midnight and 2. And I don't think any parent wants to do that during lockdown at the minute. They want them fast asleep as early as they can get them, probably. So we're sort of struggling with that. And we sort of said, well, by the time September comes around, maybe we'll have a better chance of doing that. But, we're fingers crossed they'd probably be back at school by then. So it's a little bit up in the air, I guess. But I think if parents are looking for resources, they're definitely out there. And obviously that Ram's list is a great place to start with that. But the Zooniverse also, you can just sort of leave them going, clicking away on various different things and knowing that they're at least doing something useful. So
that's brilliant. Thank you very much, both. Okay, so we've actually got a question from the audience. So a curiosity question. Do we also see a spike in other Zooniverse projects other than Galaxy Zoo, like exoplanet hunting, etc., due to lockdown?
Yeah, as far as I know, I don't know the exact numbers. I knew the Galaxy Zoo stat for tripling, but I know there has been a huge uptake. And something else I heard as well, which really made me laugh, because this is such a UK focused thing, but you can see spikes during bad weather and drops during nice weather. So at the minute, it's really warm here today. It's like 30 odd degrees. So I know there's going to be a drop in classifications today because everyone will be outside. But I think, it's kind of cool that you can see that when you do filter for UK sort of IP addresses. So you do see a spike with all of the projects, going into lockdown. But especially also we have a bias with projects that get new data. People might think, okay, well, original Galaxy Zoo, which was those million classifications, finished, in the first 6 months. But everyone here will know, as astronomers, we don't stop taking data. We've always got more data to be looked at. And so there's always projects that are getting a fresh influx all the time, whether that is the Galaxy Zoo project or the Exoplanets project that's currently running and getting data from the TESS spacecraft sort of periodically as well, or whether that is the Penguin project from Antarctica that's getting their sort of download dump of penguin images from the South Pole. So whatever it is, we do see the spikes here and there, which is nice to see.
We have another question I see here. So are EO and astronomy, so Earth observation and astronomy, the perfect topics for lockdown? So maybe Hayley, talking about Earth observation, if you want to sort of...
Yeah, I mean, I guess I can respond to that in kind of two ways. I mean, EO is a topic for lockdown. I mean, we've been able to see pretty much everything that's going on in huge changes in human behavior using Earth observation data. There's been quite a few articles published recently just showing like how things like, for example, air quality have changed, how people's movements with cars have changed. You know, it really does show that you can use Earth observation to see all these different parts of our day-to-day lives. So in that sense, yeah, it has a very direct relationship with what's going on at the moment. And the second thing is, you know, Earth observation, or as you might also hear it called remote sensing. I mean, the key's in the name there, that it's something we do remotely. I mean, I'm a marine scientist. I live miles away from the sea. I don't see the sea. I haven't seen the sea now in, oh gosh, about 4 or 5 months. And I study it. So, you know, it really does show that you don't actually have to leave your house even necessarily to access all that information that is out there, thanks to our satellites that we have orbiting the planet. So yeah, I would say it's, you know, it's a very amenable topic to our current situation.
It's so great that, you know, all the effort you guys have put in here of making that data available. You know, like you said, for anybody who wants it, not just scientists, but we actually have some of the Earth observation projects on Zooniverse too. So we have one called the Planetary Response Network, which is specifically only after natural disasters. So for example, after some of the hurricanes that hit Puerto Rico last year, like we took some of the before and after imaging data so people could locate where there'd been road blockages or floods or, you know, down tree, whatever it might be, or like mark where like rescue teams needed to get to very quickly after the disaster, which is really cool. But then also like we've got a project that's looking at sort of where the kelp forests are, you know, off the coast of Canada, which all comes from that kind of satellite data too. So yeah, it's amazing like how that those two completely different fields of like astronomy that set off one thing could like link with then the work that you're doing.
Yeah, there's a huge amount of cross-fertilization between these subjects, especially, I mean, I used like various astronomy methods during my PhD. This was exoplanet detection. I ended up using the same algorithm methods to apply to satellite imagery. So they do interact really, really closely. And you've touched on something that I think is super, super important is, as well as the like remote aspect of it, we do actually need eyes on the ground. You know, validation data, as we call it formally, is super, super important for Earth observation data being of high quality. And often you need a lot of that validation data. So citizen science projects, they're actually able to help us like quality control, check, learn more, classify our images are, you know, a growing and super important part of what we're able to do now.
Yeah, because I mean, people always say like, oh, can you not just like throw machine learning at this problem? And you're like, well, we could, but as long as we have like a gold standard data set that we can train them on.
Where's my training data?
Yeah, and we need humans to make that. And you know, like I think we did something with Galaxy Zoo where you needed something that was like 4 or 5 times bigger than the current set that we had to train a machine algorithm to be more accurate than a human, for example.
Yeah. And this is a particularly big problem for the oceans because the oceans are really diverse, they're moving all the time, and we don't have physical access to them. So, you know, things that where we can try and gather more and more of that information is really important. Citizen science is one thing, ships of opportunity are another thing, where people are out on yachts and ferries, and hopefully we'll be able to do more and more of that again as, you know, the situation eases here with COVID. They are really, really vital for us.
Fingers crossed, yeah. You mentioned the algorithm that you use for exoplanets, but in your own research, one of the other crossovers I know of is that the algorithm that's used to detect where you are in the night sky, sort of like if you took an image of the night sky and you have to triangulate amongst all the stars to figure out where you are, they use the same algorithm to figure out which specific whale shark that researchers have found in the sea, like from their markings. You know, the whale sharks are the blue ones with the white polka dots. They use exactly the same algorithm, and that just blows my mind.
That's so cool.
Yeah.
And just
we've
on
actually
that
got another question from the audience. as questions for Haley specifically, actually. What type of content is UMetSat offering? You mentioned courses. For who are these courses?
Yeah, so we offer a lot of courses throughout the year. We've got some that are open online at the moment that you can view kind of at your own self-paced. And then we have various ones that we advertise, we take applications, then we have interactive elements too. Normally those would be in a classroom environment where people would come and meet us in a certain place, either here in Germany or in one of the host organizations that we work with around the world. But at the moment, that's all happening online. The courses are nominally open to everybody. I mean, most of what I'm doing is working with Copernicus data. So this whole ethos of kind of open science is there. So, anybody from a scientist, a researcher, a journalist, through to somebody running a consultancy, an oceanographic business, or working in a government context would be eligible to attend these courses. We usually ask people to write a motivation just to check that we can, meet what it is that they need from us. But yeah, normally they're open to everybody. So if you're interested, check out our website. It's training.umetsat.int, and you can see what we've got and apply.
Brilliant, thank you. Ryan, did you have another question?
Yeah, I think the very last question, I guess, to Ramasamy, how exactly do you sort of engage people in astronomy when this is from lockdown because of the sheer sort of isolation of it? How do you kind of keep people engaged in activities?
Yeah, that's a good question. I think initially our hopes were low, but last week, as you may know, there was this annular solar eclipse visible across most of Africa and large parts of Asia. And what blows my mind is that the entire eclipse, from the planning organization to live streaming the eclipse, everything was carried out online. So maybe this is the first time an eclipse has been entirely planned and viewed online. So I guess we are a place where everything is possible, done, it can be done virtually. There are remote telescopes available for anyone, so you just pay a little bit of a fee, and then you can get to see the skies through a telescope in Australia or Chile or in other parts of the world. But we also have a couple of specific programs. So one current program is called the Meet the IAU Astronomers program. So we ask people to submit some basic details of the target audience and what kind of topic they want the astronomer to talk about, what language and so on. And then we'll match this request with one of the astronomers of the IAU, and then there'll be like a virtual connection. And the other one is we're also trying to encourage people to think creatively, I guess, by offering sorts of rewards and running a few competitions. So hopefully this will keep the interest sustained within the community.
Okay, thank you, Ramasamy, and thank you to all our panelists there. So hopefully you've learned something and can occupy yourself a bit more during these the strange times that we're in. So thank you, Ramasamy, thank you, Becky and Haley. So yeah. So next, what we. Oh, okay. Oh, you're heading off, Becky. Okay. Bye,
it's
Becky.
tea time.
Thank
I'm
you.
hungry. Bye, guys.
Yeah. Bye, Becky. Thank you. So thanks everyone for the time. So next we're heading into an open Q&A and discussion. So anything that's been addressed this evening so far, then we are sort of opening up the floor. So anyone who has any particular questions, and this could also come from people that have spoken. So if you've got any particular questions to other speakers, yeah, do feel free to sort of come in here. So yeah, it's very sort of open.
So we do actually have a question already, Ryan, from YouTube. It's directed directly at Ram, so kind of a good follow on from the panel we just had, actually.
Okay.
So Just a quick question to Ram. Does OAD do any private partnerships in the time of lockdown in Africa, like traveling telescope, to extend the outreach efforts? Are you still here, Ram?
Sorry, could you repeat that?
Yeah, sure. Just asking whether OAD does any private partnerships in the time of lockdown in Africa, like traveling telescope, to extend their outreach efforts.
Sorry, I just took off my headphones and there's a bit of an echo. So was your question, does the OAD have private partnerships?
Yeah. Let me just. Did you get that, Ramasamy?
Yeah. Okay, I see. Thanks.
I think your connection dropped there, Ryan. But okay.
No. Well, yeah.
Yeah, I can see the question. Thanks. So we do have a few partnerships with astronomy organizations and universities and so on. But I guess we do have a good relationship with a lot more organizations. So not formal partnerships like the traveling telescope one. We know the people running it and we've known each other for a lot of years. So I guess there's a sort of mutual understanding in running joint activities and so on. If that answers the question.
Brilliant. Yeah, it does. Thank you. We've got a question for Marco now. Is Marco still around? Yep. So Marco, how did you get involved in space, being from a country that has no space program that we know of?
I think Marco is muted.
Yeah, he may have left the scene for a bit.
He's on the list. Hello, Marco. Are you there?
Yes. I just went to the toilet a bit.
Oh, sorry. We got a question for you, if you don't mind. From I think from Twitter. Remco's forwarded it on into the YouTube chat. So how did you get involved in space, being from a country that has no space program that we know of, is the question.
Yes, if I understood well your question, I've entered after doing the aeronautical engineer while I was at the Air Force in Angola. We started the space program. We started running the space program in Angola. So there was a call for engineers to launch the first satellites, and I just applied as a part of the as Air Force engineer, as I had this background in aeronautics, and then I made this path to the ballistic and navigation satellite operation.
Awesome. Okay, I can't see any. Oh, we got another question. Okay, cool. So we've got a question for Gujjati. So the question is, you are 16 now. How are you planning your career in space in India?
Yeah, that's a really good question. Whoever asked it, first of all, thank you. The ground reality right now is that India is not an open, it does not have a good space policy, virtually non-existent space policy. And the only space missions which you hear of are run by ISRO. And yeah, we have good engineering colleges when it comes to aerospace in particular. And I intend to join, I intend to do my undergrad in either MEC or aerospace, but master's in aerospace, especially towards propulsion. And yeah, there is scope in India for that at least. So yeah, that's what I hope for.
Okay, brilliant. There's actually another question for you, which is what inspired you towards plasma propulsion systems?
Oh, yeah. The thing is, like, I've been passionate about space since my grade 7 or grade 8. I was reading these books, and yeah, I had rocket propulsion elements in grade 9. The thing is, what I was observing all around was there's a lot of focus on chemical rockets and other things which quite didn't get me. Like, if you say chemical rocket, it has a good thrust, but it has a less ISP. If Elon Musk is dreaming to send using that, if he's planning to send it to Mars or Moon, yeah, it sounds good. But one of the main reasons was it's Europa, first of all, because what I felt was I did a project once in my school where we had to design this. It was what NASA aims, that planetary colonization project. I think you all must have heard of it. So it was just designing a space station around Europa and all. And the research which I did, I'm like, man, this thing has potential. And I was just looking for propulsion sources, and chemical didn't give me the answer. And fortunately, plasma gave it, and I dig deep into it, and yeah, I just fell in love with it. So yeah, that's how it ended up.
Awesome. Well, I honestly wish you the best, and I hope you actually managed to get into plasma propulsion after college and everything like that. We've actually got a question for Burt now. Burt, are you still around?
Yeah, I am still around.
Awesome. Okay, so I've got a question for you, and it is, does your GNSS community have any formal links to the GNSS providers? Can they use your findings to improve their systems?
So I partially understood what you said, so I'm checking the stream maybe. Yeah, do we have formal links? No, we have no formal links at all. But we do have a lot of friends, especially in the various Galileo bodies, but not within GPS, for example, because GPS is far more of a military organization, and they're not as good at sharing rumors or interesting graphs with the community as the civilian Galileo people. So we have no official links, but I would somehow I would find it fun. So we try to be helpful, and sometimes we can be helpful. And if someone would say, hey, do you want to officially help us, that would be fine by me. But on the other hand, it's pretty nice that we are now completely independent. And because that was one of the original problems last year when there was this Galileo failure, when almost everyone involved with Galileo was not willing to go out and say, well, this is what is going on, because everyone had a commercial relationship with everyone else. And so we, as an independent body, we can have a lot of fun and say, well, this is what is going on, or your quarterly performance report is too optimistic or whatever. So no, we have no links. It would be fun to have some kind of links, but it's also very nice to be as independent as we are today.
That's brilliant. Thank you very much, Burt. Okay, so I think we're just about wrapping up now. But we do have one final question, which is when can we expect SpaceUp number 3? And actually, we do have one in the works. We don't have a date yet, but we can tell you it will be during World Space Week in October this year. So keep your eyes peeled, sign up on many lists, and you'll hear about it in due course. I'd also like to take a moment to thank all of our participants, our T-5 speakers, our grid speakers, and our panelists. A fantastic array of talks, really interesting, and I can't wait to see some new talks in the 3rd edition. So if you guys want to talk again, then there'll be same proposals coming out, just kind of mixed up a bit of different talks. Then yeah, Ryan, do you want to say any words?
Yeah, thank you so much, everybody, and thank you also our audience online. So yeah, this is the 2nd edition. We're learning, of course, as we go through this, and we plan to bring you a bigger and better edition during World Space Week. And yeah, and finally, I give the floor to Remco as the CEO of SpaceUp. So.
Sure, yeah, thank you very much. And well, it's, I guess, my role to thank you, Ryan and Ryan, for organizing a very successful second edition of SpaceUp Live. So thank you very much. And it's great to hear about your plans. And I kind of knew, of course, about the plans for World Space Week, which I'm very pleased about. So keep an eye out on the website, spaceup.org, and the Twitter, Facebook accounts of SpaceUp for further announcements. And I would like to thank our speakers from all over the world. And I'm very happy with the fact that we do this online, that we get people from everywhere. We have people from Europe, from South America, from India, from the rest of Asia, from Africa. I'm really pleased to see how our platform can really engage people from all over the world. And that's really what we want to do. We want the space community to be a global community, that it of course is. We want to highlight that by specifically inviting people from all these regions around the world to show people that space really unites all of us from all over the world, and that this is not a European or North American game only. So thank you very much from joining us from all these different time zones, and I'm really looking forward to seeing you all again at our next virtual event, and hopefully someday as well, of course, at live events in person all around the world. So thank you everyone for joining, and thank you to our audience for joining us on YouTube. It's 2.5 hours is long, but I think we offered you a varied program with different views, many very different topics all around space, and to help you find your ways into the space industry and to stay connected. So thank you very much, Ryan and Ryan, again, and hope to see you all again soon.
Thank you, Remco. Thank you, everyone, and see you again next time.
Bye all.
Thank you very much.
All right. Bye
Thank
all.
you,
Well done, guys.
Remco.